share my screen. Okay, is the screen share working?
Yep. Yes, sir.
Great. Okay, we last inserted a couple rows into this calls table. And now we're going to see what happens if we insert a record for a contact that doesn't exist. Wow, that's interesting. So it didn't stop us from doing that. So we now have a call for contact, 99999, and there's no such contact. So that is invalid data. So to clean this up, let's delete that table and replace last ID with the actual ID, which in my case was 5. Okay. We are going to add what's called a foreign key constraint. So Jake talked about this a bit in the intro presentation. But a foreign key, we'll define the terms a little more carefully now. So we talked about before, a key is a unique identifier. A foreign key is when in one table you have a unique identifier for a row in a different table. And a foreign key constraint tells the database, make sure these references are always valid. So now that we've added this foreign key constraint, which the syntax, again, is something you'd actually just look up mostly. But you say, I want to add a foreign key for this column in my table, and it's in parentheses because it potentially could be multiple columns. Then you say references, well, which table am I referencing? Contacts. And then in parentheses there, you give the list of columns that are the key you are going to be referencing. All right, let's try this again. All right, it stops us, and that's a good thing. I've had cases where with a different database, it did not have near as many data constraints as Postgres does. And really, it's a matter of, are you going to have a bad time now or a bad time later? A bad time now is much better in that an error occurs, oh, I need to fix something. A bad time later is, oh, well, I thought I had all this data in my database and it's all messed up. That's not good. So in this particular case, in this particular other database, if you inserted an invalid date, it would just change it to all zeros instead of telling you, hey, that's not really a date. Or even saving the invalid date, it would just nuke it and just save zeros. It's like kind of a strange decision they made there. But back to foreign key constraints. So you almost always should use foreign key constraints. Occasionally, there may be some sort of, there is a performance overhead. So at extreme scales, I have heard of people needing to loosen these foreign key constraints for performance sake, but that is exceedingly rare. So this is another one that I'll qualify it with almost, but practically speaking, you should just always use foreign key constraints. Okay, we've got 2 tables. Now we're starting to get to, this is really what makes SQL special as opposed to other database types. Jake mentioned, or he had a list of several popular databases from I believe it was a Stack Overflow poll. And I believe the next one down the list was Mongo and then Redis. And one of the different things about a SQL database versus, like Mongo or Redis or, a number of other ones is most of those other ones are some variant of a key value store. And they can be super fast. A key value store means you save just a blob of data and you have a key for it, just some number, and you can very quickly read things back. But Postgres and SQL in general can do some processing on it. And in particular, they can do processing on the connection between various rows in various tables. So we're going to start with joins here. And we'll start with the very simplest join. And that is what's called a cross join. Now let's look at this for a second. So the columns on the left, name, phone, and ID, those are from our contacts table. The next columns on the right are from our calls table. This ID, contact ID, call start, call duration. Now, the way we've joined these together is actually not terribly useful. In fact, it's basically meaningless. But we're starting here because this is the very simplest join. And what this join type does is the table on the left, and by left, I mean, if we had these like on the same line here, the left side is contacts, the right side is calls. The table on the left and the table on the right, we create a new row for every combination of rows. So we can see here that first of all, we have every row from contacts matched with row 1 from calls. And then we do the same thing with row 2. Then we do the same thing with row 3. Then we do the same thing with row 4. And that actually is also apparent when we look at how many rows were returned. We had 19 contacts and we had 4 calls. You multiply those together, you get 76. So normally, we don't use cross joins. Probably 1-2% of the time, maybe. What we use 80 or 90% of the time is an inner join. And SQL lets us omit the word inner. We can put it here if we want, but why do any extra typing? You don't have to. So usually it's just, select star from table A, join table B. So let's run this and let's see what happens differently. Okay, so what happened here? And joins are a big deal. So we're definitely going to want to make sure we really get this. So what the inner join does is it only includes the row where the on clause evaluates to true. So from our contacts table, and that was something I talked about at the very beginning of the morning, where I said we can prefix a column with the table name, so contacts.id, and we generally only need to do that if we have multiple tables. We are doing that here. So the ID of the contacts table, which is this right here, where it matches contact ID column of the calls table, which is right here. And these are the 4 rows where that matches. If we go back to the cross join, we can see that there's a whole bunch of these where it does not match. This does not match. This does not match. None of these match until we get, to here. Now we have one that matches. And a whole bunch that don't match. So the mental model that's useful to visualize this is we start with a cross join. Every possible combination of all the rows on either table. Then we're going to filter it, where only include the rows where this condition is met. Any questions on that? It's usually kind of confusing the first time people see it.
Hey, Jack, the output of a join, is it just display only unless you specify somewhere to store it?
Yes. Yes, in fact, that's true for just all select statements, unless, a select by itself is always here's the result, and it's not permanently stored. So yeah, it's also sometimes, if you read the literature, it'll be referred to as like a projection, is another word that you may run into occasionally. But yeah, it's like punching in something into a calculator and saying, give me the answer. It doesn't save it there.
So for a join as opposed to a where, if you have a single table, you can use a where and logic or something like that. But if you're doing two tables, that's where it needs a join. Did I understand that correctly?
Well, not exact. Kind of yes in practice, but not technically. So we could, if we go back to this cross join, we could put the where clause there. And we'll get the same result. And you may, if you read old database stuff, you may actually see something like this, where they just have a from and they list all the tables with commas between them. A comma is basically the shorthand for spelling out cross join. And as far as what it actually does, these are identical. However, what people realized over time, and what is the, how would I say, what's the word? What is the idiomatic way of doing it now, is to use the on clause instead of the where for join conditions. So your join conditions go in the on clause, and then you still can have a where clause. And the idea is, even though you could put everything in the where clause, it reveals your intention better to say, well, this particular thing is how these tables are joined together. This thing is how I'm filtering the rows once they're put together.
Got it. That makes sense.
Okay, so there are several more types of joins. We're going to go back to joins in a few minutes, but we're going to make a little segue and talk about aggregate functions. So aggregate functions are another, how would I say, another concept that oftentimes can confuse people the first time you see it. And that's one thing, I didn't mention this at the beginning of the lesson, but one thing I hope everybody understands, just for like this whole like code platoon thing in general, but what you're trying to do is really hard. So if you get frustrated or like, man, I see something, I don't understand it, it's not you. It's really, really hard. And this is another concept that usually, the first time somebody sees this can be quite confusing. So we're going to do a number of examples here. I definitely want questions. I'll try and explain it a few different ways. And hopefully we'll get through that initial wall of confusion that is usually encountered here. So an aggregate function reduces multiple rows into one. In fact, if you probably haven't gotten this far in Python or JavaScript, but you'll probably run into a function called reduce at some point. And it's a very useful, function that you'll find. Aggregate functions in SQL and reduce functions in other languages are very similar. If anybody has done reducers before. But in this case, let's just start here. So we are going to, do this select, whoa, that was in the wrong window there. Okay, select count star from calls. So this tells us how many rows are in the calls table. Now, count star is kind of a special, the star there is special. That means count how many rows there are. And what does this actually do, though? So the way aggregate functions work is we have some criteria by which we are going to group the rows together. So maybe we have, millions of rows, but we have 5 categories we want to group them into. Well, then there's going to be essentially those 5 groups. maybe we have, maybe it's something with US populations or something, and we want to group by the states. So we're going to have 50 groups, for example. In this case, we are not telling it any specific group. So it's going to say, oh, we just must want one group. So if we're going to put everything into one group and count how many things went into that group, well, 4 rows went into that group, the group of everything. We also have a function, just like we have a function to count, we have a function to sum. And that does what you'd expect. It adds up all the elements it's given. We also have average. And again, does what you'd expect. That link to the documentation there, if you poke around there, you'll find there's maybe 20 other ones or so, something like that. There are all sorts of different, these are the common ones, but you also have stuff like standard deviation, a couple versions of that. You have max and min. You have several that'll build like JSON documents or XML documents, various things like that. You have things that'll aggregate stuff into an array. But these are the common ones, and these are the easiest to learn with. Well, let's go on. So group by. Group by is how we tell it, well, how many groups we're going to have. So let's run this first one here of select contact ID, star from calls. Cool. Okay, so here's what this actually did. I'm going to start with this. And again, it's really important to get that mental model of how do these tables relate together. And we have all these tables come in, we give it these select statements from, where, group, all these things. And then essentially a table comes out. It's not a permanent table, but we get a rectangular result set. So here's what's happening here. This is the underlying table. And what happens where we get this? So the mental model to have here is it goes to row 1. And it says, okay, I am grouping by contact ID. So the contact ID is 1. Okay, do I have a group or a bucket? Sometimes I refer it to. Do I have a group for contact ID 1? Okay, I don't. So I'm going to create a new group for contact ID 1. Okay, I have the group now. What am I going to do with it? Well, I'm counting things. So, okay, so I'm going to pass this row into this count function. And all count does is just, well, increment a counter. So I now have a group for contact ID 1, and its current value is 1. So I'm going to actually do that here. I'm going to say contact ID 1. And our counter is 1. We go to row 2. We see, oh, contact ID 2. Do I have a bucket for contact ID 2? I don't. So I'm going to make a new bucket for contact ID 2. And I'm going to feed this row into it. Okay, so what do I do here? So I increment the counter. So I'm going to say it's 1. I go to the next row. I say contact ID 2. Do I have a bucket for that? Yes, I already do. Okay, so then all I do is I feed this row into that count function, and it does its increment. Then I feed in the next row. And we say, okay, contact ID 2, I already have that. Feed the whole row into the count function, and we end up with this. And we did not supply an order by clause, so obviously order is undefined here, but these are the same results we got. We just did it by hand. Any questions on that one? Like I said, I know it's a little confusing the first time you see it, but.
So I do, because the table that you get, the 2, 3, 1, 1. So you're doing from. Let me see. So you're doing from calls, but if you wanted to access the contact information, like for that table, to do contact ID, the name of the person, and the count, would you be able to access the other table even though you did from calls?
What we would need to do is we would need to combine that with what we did before this. So we would need to do a join and then group by contact ID as well. I think, let's see here. Yeah, in a couple more examples, we are going to join those together. And again, we'll try and build up that mental model of, which order do these things get, what order do all these operations get performed in, and how do we combine these things together? So the next examples are similar. It's just instead of counting how many calls, we sum up how much time there was, or we average how much time there was. And it works exactly the same way as what we did here, where it goes through each row, figures out if it needs to start a new group, and then it feeds in the value into that aggregate function, which keeps some sort of state for each group. And then when it's done with all the rows, it gives us that state, whether it's counting all the rows, whether it's summing up the call duration, averaging the call duration, whatever that may be.
So really select is like display.
Yes, yes. Select is actually about the last thing that happens. That's one of the complaints about SQL, in that the order you write the stuff is not at all the order that it happens in. Select really is the last thing that happens.
I did have a question on order, actually.
Okay.
I noticed when you put in the backslash statements, it did not require a semicolon, but \d did accept arguments. So I was just wondering what is possible with the backslash statements, considering there is no end, or how it would take in that information, or.
Right. So the first thing there is backslash statements are meta commands to the actual psql tool. So if you use Python and you connect to Postgres with the Python tool, whether it's Django or you use, what is it, PsychoPG, I think is actually the database driver they use, something like that. I might be wrong on that, but if you try and use a backslash command there, it's not going to work, because it actually is, the backslash is saying, hey, don't send this to the SQL server. You do something with it here. So yes, it has an entirely different syntax that doesn't need the semicolon like SQL does, because it's like trying to think of an example. What would be another example? Maybe like in your shell, where some commands are actually to the shell and some are actually saying run this program. That might be a rough analogy, but yeah, the idea is this is going to the psql thing. And for what you can do with it, if you \?, it gives you the list of the different things you can do. And there are a lot of them.
Okay, thank you.
And along that line, \h gives you the list of actual Postgres keywords. And you can get the basics of it directly in the tool. And it'll give you the link to where you can get more information. Okay. All right, let's try this. That didn't work. Let's read the error message and see why not. Column calls.callStart must appear in the group by clause or be used in an aggregate function. Okay, and it's telling us the problem is call start. It even helpfully shows us where the problem is visually in our text. But this doesn't really explain why. It says what, but it doesn't tell us why. So why doesn't this work? Any ideas?
Call start is too unique.
Sorry?
Call start is too unique.
Yeah, I'm sorry. I heard like call start is unique. Was that what it was, or?
Call start is too unique or too specific, so it's not aggregated with contact ID.
Yeah, I guess saying too unique that's kind of right. The question, or rather the thing that really clarifies it here is when we did this one, this is the same query just without call start. So we're going to end up with 2 rows because we're grouping by contact ID. So somehow these 3 rows are going to be squashed down to 1 row. Which call start should we use?
Are you saying which call from the header?
Well, I'm saying that we have these 3 rows that are being squashed down to a single row by the group by. So somehow we have 3 options here for call start, but we only have 1 spot for it to come out. So what do we do?
I guess, can you specify like time or something like that, or the date?
Well, we could specify it, and that's actually, I guess, the answer to the question. Why is this an error? Because there's 3 possible things, and it doesn't know which one to choose. We could tell it, for example, if we wanted the earliest time we ever talked to that person, we could say min, now it'll work. But without telling it which one, all it can say is, you've given me multiple things to squash down to 1 thing, and you haven't told me how to do that squashing. Or you've given me 3 values that need to be reduced. Probably, I suppose reducing or aggregating is a more technical term than squashing. But so yeah, we have 3 options. It doesn't know which one to choose. We have to tell it. So you'll probably run into that question occasionally. Like, for example, in a couple minutes when we do join with the contacts table and we have the name, we're potentially going to have to group by the name as well, just so it knows. And that's another thing. This error is syntactic. I said the problem is there's 3 things that need to get reduced to 1. Technically, even if there was only 1 thing, it would still complain because it would detect ahead of time that it's possible an error would occur. So it would require us to be more specific up front. Okay, here's another example. We can have multiple aggregates in the same query. Pretty straightforward there, I think. Nothing really new aside from just combining some of these things. And lastly here, we are going to finally get to joining and grouping. So let's look at this here. I suppose we'll start with just running this, and then we're going to go through kind of start to finish the process of what is the database actually doing, what is the mental model for how all those things interact. So this is pretty cool. We just have a couple lines of code, and it did an awful lot of calculations for us here. It figured out, who have we talked to, what is their name, so it joins to find their name. It counted how many calls. It gave us the sum of how long we talked to them, the average of how long we talked to them. This type of stuff is pretty cool. If you try and write out like a Python or a Ruby program to do this by hand, those languages are pretty expressive, so it's not terrible, but this is a lot easier. Okay, so a couple new things here. One, we are grouping by multiple columns. We need to define our groups or our buckets uniquely, but we can have any number of columns that do that. So the rule for group by is every column in the select either has to be included in the group by, or it has to be part of an aggregate function. And there's a small exception to that where it's basically a shorthand that lets you avoid having to type so much. But mathematically, basically, this is the rule. It's either grouped or it's aggregated. Now let's see what this actually does. So the way to view this kind of step by step is we're going to start back with our cross join. So we have from context join calls. So this is where we started. But we don't want to do the cross join. We actually want to, only include the rows that are correct, or that match each other. So then we end up with this. Next is where the group comes from. And that's what we talked about before, where it goes through, okay, I read this line. Okay, group by contact's ID and contact's name. Okay, do I have a row for this? Or a bucket or a group for this? I don't yet, so I'll create one. Then for every one of these aggregate functions, the aggregate function gets called for that group with either the star, which just says, the whole row, or the particular column. So it's going to pass call duration into sum, and the state of the sum function will be updated every time, a new row gets passed in. So we do that for each row. Then kind of as part of that, the select thing is the last thing that happens. So then we, grab the values of all those things for each group.
Do you have to do the from contacts, or can you just do join contacts.calls?
You have to have the from. So that the major clauses, is the select, the from, where, group by, whatever. But from, that is required to have anything you can read from. So that's the join part is actually basically a subclause of from. You could kind of think of it really as if it was in the where clause where you say like where A equals B, this is actually kind of similar there. We're saying where, from context join calls. Because in theory, what comes out of the from is just one giant table. It's like this comes out. And then past that, everything else doesn't need to know even that it originally came from multiple tables. You just have a single, potentially very large spreadsheet, essentially, or table. And everything processes that single set of rows. Okay, one thing we're missing though. So if we said, I want this aggregate information on all my friends, well, we had 19 people in our contact list and we've only got 3 people out of this query. So what if we want to count the people that we didn't talk to, or we haven't talked to as long as we've had this phone? It is almost exactly the same query, except for one word. That one word is left. So instead of using a normal inner join, we are using what's called a left join. So what the left join means is, again, figuring if these run the same line, the left table is to the left of the word left join, the right table is to the right. We are saying with a left join, we're saying every row on the left we want to include. And if there is a matching row on the right based on this criteria, we want to include that as well. But if there's not, we just want to put a null value there. And we can see what that looks like a little better. If we do this command to run it without the group by, we can see what this looks like. So this is the underlying data that comes out there. And you'll notice we have our matches like we did with the inner join, but all the other rows simply have null for every value for the calls table. So far, so good.
Can you go over one more time what that left keyword means?
Yeah. So what it's going to do the exact same type of join, only like for this row that I'm highlighting here, all of these rows, the inner join says, oh, there's no match, so I'm not going to include a row there. The left join says, I'm going to include every row on the left table. So every row from contacts will be there. But I want to try to join it with calls. And if I succeed, great, put the data there. If I don't succeed, leave it null. So another way of thinking of left join is try, where regular join is, must to do, where left join is try the join.
Gotcha, thank you.
Mm-hmm. So let's talk a little bit about null. We talked about that before, that one of the values of null is empty. And that's loosely been true so far, that whenever we ran into a null value, it always meant empty. However, at this point, we're getting to where it's still kind of true, but we really need to start expanding our definition of that. And to explain that a little bit, I usually, when I do this in person, I actually can have some props. That's a little harder over Zoom here. Well, let's see here. So I have, I'm going to stop screen sharing for a second so y'all can see. Okay. So I have something in each hand. Is the thing in my left hand equal to the thing in my right hand?
We don't know until we compare.
The answer is null.
No, well, you're both right. We don't know, and the answer is null. So in this case, no, they're not equal. I've got a thumb drive and a little plug thing for a cable. But maybe my hands were empty. Maybe they had the same thing in it. Who knows? But the fundamental thing there is, if we are comparing another way of stating it more mathematically is unknown A equal to unknown B? There's no way to know. They're unknown. You can't say, no, they're not, because they might be. But you can't say they are, because they might not be. Whenever you're comparing something with an unknown value, the only correct answer is to say it is unknown. And in SQL, null serves double duty, as it may mean empty and it may mean unknown. Now that leads to a lot of confusion. This is another one of those things that expect to be confused the first handful of times you see it, and expect for the first few years of your career to get bitten by this occasionally when you forget about it. So let's do a little SQL here. Let me share my screen again. So down in the SQL thing, it's fairly obvious to say that, like, does true equal true? Well, that's true. Does true equal false? No. Does false equal false? True. Does true equal null? Well, null. I would expect that to be false. You know, your intuitive thing, it looks like, okay, the thing on the left is not the thing on the right, so it must be false. But since null can mean unknown, it might be true. So all it can say is null. What about, this is actually the one that really trips people up a lot. They'll say, does null equal null? Well, null.
One might be unknown and the other one might be empty.
Sorry?
One might be unknown and the other one might be empty.
Yeah, yes. Yeah, now, I mean, that's kind of tricky here because null will, we don't even know which meaning of null is being implied there. That's another annoyance with SQL. You could make a case that instead of null, it really should have empty and it should have unknown because they kind of mean distinct things. It's common to use null as a value, like say you're working with a some sort of subscription service. So you have a start date and you have an end date for their subscriptions table. Well, if they're a current customer, you probably have an end date of null, meaning they are still a customer. You know, end date is empty, as in it has not ended yet. But you also might have, let's say you had a database of people from the 17th century, and you have their date of birth and you have their date of death. Well, if they were people, they were all born. And if they were born in the 17th century, they've all died by now. So neither of those is empty, as in it hasn't happened. But they very well, both of them could be unknown. And it would be nice sometimes to distinguish between those cases. So if we actually need to compare specifically null, there is a construct where we can say is null. And this is actually an operator like equal, where we're just saying, is this thing null? And null, well, is null. So to, it probably looks a little funny there. But we can say, you know, select, you know, if ABC was a column, it would return true or false depending on if it was null or not. And there's the converse, we can say is not null. Any more questions on that?
I had a question about one of your examples. So you was talking about the subscription and the end date and how it's unknown. How come you wouldn't use something, say like a Boolean, to say that their end date hasn't happened, so it's false, or like then they do end it and it's true?
So you could, and that's depending on exactly how you want to represent the data. And that type question is actually, we're going to dive into that a little bit when Jake leads us through a data modeling exercise as one of the last things of the day. But we'll give you a little bit of a preview of that now. So the trick there, that would be better in that we could represent all possibilities. As in, we could say, are they a current subscriber? You know, let's say this is for a magazine that you know, goes back to the 1900s or the 1800s even, and we have their historical records. we may know that somebody from 80 years ago, they are no longer a subscriber, but we also don't know exactly when their subscription ran out. So in that case, splitting it to 2 columns where we can say, false for current subscriber, null for end date, that is how we would have to represent that to encompass that idea of they are not a subscriber. We also do not know, or rather we'd say their subscription has ended, but we don't know when it ended. So 2 columns there, that would be how we represent that. Why we would potentially not do that is if this is a new company, for example, we may not have any records where we do not know when their subscription ended. And in that case, deciding that null means it hasn't ended yet means there is less potential ambiguity. So in our new company case, we may want to have a data rule or a business rule that we always know that. And by representing the end date as a nullable field, that means we either know that it is still in progress or we know exactly when it ended. But our data model cannot represent a subscription that has ended and we don't know when it ended. And both of those can be valuable. We have to decide, should our data model, do we want to be able to represent that? If we do want to represent that, we use the 2 columns. If we don't want to represent that, we actually want to use the 1 column because that is essentially invalid data that now we cannot represent.
Yeah, if I could add an example there, Jack. One thing you see a lot with databases is a concept of soft deleting something. So this used to be the way that all data was treated, but now and with GDPR and modern approaches to data, it's quite as popular. But there used to be this idea that you don't delete things, right? So if a user says, I don't want to be a user anymore, you tell them that you have deleted their account, but what you actually do is something called soft deleting. And soft deleting would be like basically saying this record is deleted, but it's not deleted. So the argument for doing that is that like you don't lose all the information, you don't lose all the references to that record. The argument against doing it that way is obviously you're not really deleting it. So you're kind of, if the person thinks you actually deleted it, you're not being quite honest. But anyway, the way that that's often represented is a timestamp on the record that says deleted at. And that's just known as a way of saying this was deleted, as far as what that means. But that could be a Boolean, right? Instead of deleted at, it could just say deleted, and it could be true or false. But I think that that's a pretty good example of where a timestamp is great because you have essentially a Boolean. If the date's there, it was deleted. If the date's not there, then it wasn't deleted. But also it carries this whole other thing, which is knowing when it happened.
Yeah, and actually another example of that as far as like soft deletion, so to speak, a similar one is what we looked at originally with Postgres, where it has all those hidden columns and they internally record when was this thing created and when was it deleted. Now it never exposes that, or it's more of an internal bookkeeping thing, but that's a similar type thing of maybe we store the timestamp of the deletion rather than just true or false.
So I definitely get what y'all saying. The way I kind of think of it, how y'all explained it, is almost like with hard drives. Whenever you delete something on them, basically the hard drive says don't access it at this address, and then it's still technically there until you add enough data to actually override the zeros and ones. That's kind of like how if you delete something on a hard drive, it can still be recovered possibly unless it's actually been overridden.
Yeah, I think that's a good analogy. In this case, with soft deleting, you're planning to never overwrite it. But yeah, that the old way, I think the older way of looking at data was like, just don't delete anything. You'll always be glad you didn't delete it. And I mentioned GDPR because recent privacy laws are pushing back on that and saying that users have the right to say, I want something to be deleted. And if you say you're deleting something and you don't delete it, then you're like not giving them that right. So that's like a bit on the legal side of all this data stuff, but it is like, it's a big change because a lot of these applications like Facebook, they didn't really write any of their code to handle that situation. They just assume nothing gets deleted.
Right. Yeah, there's a couple of things there. Like with the hard drive example, that's basically an unintended side effect that stuff exists until it happens to get overwritten. And with soft delete, it's an intentional thing of we specifically want to be able to get it back. And it's also that type thing, complying with deletion rules and stuff like that's really hard because we want to have the data normalized. So we want to have foreign keys connecting all these things. So let's say, for whatever reason, we need to delete a customer. Well, that customer has some orders. Those orders tied into our inventory system and tied into our accounting system. How do we delete that? We can't, you can't delete that. So then how do you comply with the rules? So usually there's carve outs for that type information. But there are similar things where like, how do I delete this record without, okay, like maybe a more trivial example, your Netflix and somebody, they record, everything everybody watches. Well, if somehow you cancel your account with some instructions, GDPR or whatever, that they should remove all your information. Well, how are they going to keep track? They may well be paying people based on how many times that movie was watched. Will they delete your record? How do they not also delete, that cascading foreign key of, someone watched this movie? So that gets really messy technically and legally because, can you just wipe out the person's name and the account is still there? It's just not tied to them personally anymore. That works technically. Is that sufficient legally? I don't know. Maybe not. Do you just have a counter? So you just count, 3 million people have watched this thing, and it's a counter that has no tie back to who those people are. Maybe every month or so you aggregate the data and then delete all the details. So that's part of the reason why people do soft delete, because you can just say, okay, don't look at this anymore, but all the related data that we might still need, we don't have to figure out how to not delete it or whatever. So it's a mess.
So basically, if you are a company or a business that's big enough to where it's not feasible to just stop or have downtime and then rewrite your code, basically, if you're a new company, it'd be easier to design for the future of the GDPR, I think you said it was, and to kind of have that design for that versus, someone established like Netflix or Facebook to have to stop what they're doing and then rewrite it to be in compliance and then move forward from there. From a design standpoint.
Yeah, I think if you were starting a new business today with user information, you would be, you'd be smart to consider those laws and think about. I don't know how they all apply, but you'd be smart to get like advice from counsel and be like, okay, well, if GDPR applied to, I really don't, this is not my area of expertise at all, but like if it applied to all of our users, what would we have to change? How would we have to build this so that a user can be deleted in compliance with that law?
Right. Yeah, it's really tricky. And I mean, one of the things, I don't know if y'all have heard, there was an boy, this is crazy. I was going to say an old expression. It's like 10 years old, but that's like old in the tech business. But the idea that they said like data is the new oil, and the idea the people that have all the data, it's power, it's money. And I mean, that's still true for companies like Google and Facebook and whatever, and Twitter, that the data they have is the oil, it's their big money maker. However, there's a newer version of that I've heard that I think I like a little better. Data is the new like nuclear power or waste, as in it is a lot of power, but it also produces some like really, really toxic waste that is very tricky to handle. So the way I look at stuff going forward is how can I avoid having sensitive information to start with? I mean, the easiest way not to have to secure something is not to have it originally. So that would be something I would consider as well.
Sorry about that rabbit hole, but yeah, I was just kind of curious about that from like a design standpoint.
No problem. Okay, so back to null. Let's look at this coalesce function. This is kind of an important one. So what coalesce does is coalesce says, give me the first value that is not null. You can pass it any number of arguments, and what comes out will be the first non-null value. So typically what you do is let's see here, is it this one here? We can put a coalesce on these null values here and get, normal zeros back. But before we try that, I don't know if anyone noticed and just didn't feel like pointing out a potential error here, but why does it say that we talked to all these people one time when we really didn't? All these ones here should be zeros, not one.
That's the number of occurrences in the join.
Yes. To be precise, what's happening there is our count star. I mentioned it before, but I didn't call attention to it. Count star means it's a kind of like a special form that says pass the whole row in. So it's count the number of rows. So there actually are rows for each one of these people. So it is fair to say, well, the count is 1. But what we really want is we want to know how many of these calls.ids there were. And count is special in that any null value is ignored. So if we say, if we have it count specifically the calls ID table, then we get zeros for the ones where it's all null, and we get, the numbers where we actually do have the thing. I know we're throwing a lot at you at once, but hopefully a little bit is sticking.
Sorry, could you show the difference between the two different operations you just ran? One that resulted in a 0 count and one that resulted in a 1 count?
Sure. So you see down at the bottom of the screen there?
Yeah.
Count star gives us the ones because it's counting how many rows were fed into this aggregation thing. Calls.id feeds in just that value of calls ID. And if we have the example, let's see, way back here, we can see that the matches here, we do have ID values. But for these ones that actually do not have any calls, it's null. And since null values don't, null values literally don't count in this context, then we end up with zeros for those rows.
Okay, thank you.
Mhm. So let's run this last query here. And we can see how the coalesce, sets these values to 0 instead of null. That can also be useful when you're programming something that uses SQL, because lots of times it's easier if you do not have to worry about null values, in your Ruby or Python code as well. Well, it's 2 minutes after 2. Why don't we take a break until 2:10? Then we'll do our last segment on SQL. And then we'll do our data modeling exercise and Q&A at the end. But we'll do one more SQL segment after the break, and we'll come back at 2:10. All right, let's see here. Okay, so we finished this first lesson here. We are going to move on to another example here. So we're going to break out of Peaceful here. We're going to go up to the top level of this repo. And we're going to go over, I saw somebody in the chat mentioned they'd like to do the weather one. Then we've got 3 or 4 to choose from, so we'll do weather. It's our next lesson here. So we're going to change directory to weather. And in VS Code, we're going to open up lesson.sql in weather. And the instructions are pretty similar. You create DB weather. We're going to import a lot of information. And lastly, we're going to start up the P-School client. Excuse me. All right, if you've got that, go ahead and use \d by itself. This will give you a list of all the tables in the database and other things, actually. If you do \dt, it'll limit it to just tables. And then if you do \d stations, \d reports, you can kind of look around and see what sort of information do we have available here. All right, so do we have this stuff loaded here? Cool, okay. So this data is stuff I downloaded from the NOAA. I've got the link there. If anybody's interested, you can download actually lots of historical weather data for the US from there. In particular, I downloaded data from O'Hare Airport and Jacksonville Airport. As Jake mentioned at the beginning, we met and we both worked at a company called HashRocket, and they had a location in Jacksonville, was the headquarters, and we worked at the Chicago office. So we just picked 2 different locations that were relevant to our company as our examples. So we've got a couple stations, and we have a lot of reports. Like 220,000 of them.
Huh.
So we've got a couple exercises here. This exercise 1 has 3 different questions we want to answer. How about we spend about 2 or 3 minutes trying to, you can try and solve that on your own, then we'll work through them together and talk about how we would do it. So for the question 1.1 and 1.2, here's the thought process I would use to start building this query. So once we get past really, really simple queries, you end up having to build them up in steps. So I look at this and I see, okay, highest temperature record, coldest temperature record. So that makes me think something like order by temperature, limit 1. So to start building this up, I would probably start with something like, okay, select star from reports, order by temp F, and we'll say descending limit 1. Okay, so that gives us an answer, but it doesn't tell us, which station ID that is. I don't know. So then it's like, okay, so we need the order, or we need a join. So now we join with stations. We end up with something like that. And if we wanted to, we could change the select star to just get the columns we care about, depending on if this is a report where it's like literally we just need to know ourselves, or if it's something we're building for a dashboard or something like that. But I generally work kind of like a left to right fashion as far as the tables, as in like, what is the primary row we care about or that we need to work with? In this case, you could make a case either way, but stations, you could say that's primary because that's what we're looking for. Or you could say reports is primary because that's how we're determining which one. And to get the coldest, what do you know? It's O'Hare again. We get crazy weather in Chicago.
I was confused because I figured that to do highest or smallest, you would use like an aggregate function like max or something.
That is how I also started.
Yeah, we could, or rather we need to do that for 1.3. In this case, what we would do there is we would say, what is the min temp? What is the max temp? In fact, actually, it would be, I'm going to save myself some typing there. Now we're going to, the order by and the limit don't really apply anymore, but we do need a group by. So we'd use min and max for that, that third one. The distinction there is in the third one, or in the first two, we are trying to find the row that has that highest or lowest value. Whereas in the third one, we are simply trying to find what that greatest or least value is. It's kind of a subtle distinction there, but.
Wait, so why are there 2 entries?
This is for each weather station. Sorry.
Yeah, we're grouping by stations and we have 2 stations in our data.
Oh.
So in this particular case, this is kind of interesting because this is an example of it actually doing a lot of work for us that we couldn't just visually do on our own. So like these reports here, there's 220,000 of them. And it actually goes through all 220,000. And, just like we did before, the group by is station ID, or or I guess group by, I guess in that particular query we did station's name because we're joining, but they will have the equivalent effect in this case. So for simplicity's sake, we would say station ID, do we have a group with this station ID? Yes or no? Okay, so temperature 9. So that'll be the min and the max temperature. And we go again, oh, it's 9, still 9. 8, so now we have a new min. 7, now we have a new min, so on. And we would actually just feed all 200,000 rows into this aggregate function, and it would keep track of which was the highest and lowest. Okay, so here's an interesting question. Can we find the average wind speed for each day at each station? And that's actually a really good question. Here's a query that seems to do something. Oh, and here's, I think this is the first we've run into this, group by 1, 2, order by 1, 2. Both group by and order by accept numbers. And what this means is group by column 1, group by column 2, and order by column 1, order by column 2. So for quick reporting, it can be convenient to use that just to avoid having to type the column name over and over again.
So how does that work?
How does the query as a whole work, or?
How does grouping by 2 different things work? Like it sorts everything, the second one that matches the first one, or?
So I guess, let me think of an example here. So let's say we had a people table, and we have a name of like first name and last name. We could group people by both of those things. So it'd be the combination of them as if we added them together. So in other words, if we had a bunch of records for people and we grouped them by first name and last name, it would only be a new group for each unique combination of first and last name. So in this case, what this is saying is the buckets that we're grouping things in are the per name and per day. Might actually be simpler if we run this and see the output that comes out of here. Yeah, so like each group, it's the name and the date.
Does it matter that group comes before order, or are you able to do it order before group as well?
It does matter. Group has to come first. So this gives us an answer. Oh, I guess here's one other new thing here, just where we're using a little bit of new syntax here. So reports.time, if we go back to just selecting all of these, it is actually a time. But if we care about each day, well, we only want the date. And Postgres lets us convert between types by saying : and the type afterwards. So if we have something like, what is the current time? We want to convert that to a date. We can do something like that. But as far as, is this data correct? I mean, this is one of the things that once you get past the basic syntax of SQL, this is maybe the next thing that becomes a problem. As in, we asked it a question and it's giving us an answer. But is it giving us the correct answer? Or is it giving us the correct enough answer? Let's look at the reports data again, and then you all tell me. Like looking even just at this first one here, whatever station this is, January 1st, 2010. Can we get an average wind speed from this information?
Yes, you total up the hourly wind values, assuming that they're all equally weighted. I wouldn't see why they wouldn't be.
It's an hourly average, not a complete average, because each one is just one measurement at a specific time every hour.
Right. That's the fundamental thing there is we have what we have here is a sample. It's not a continuous measurement. So, we see, okay, at 51 minutes after midnight, the wind speed was 9. At 1:51, it was 10. For all we know, a hurricane went through in the middle, but we don't sample at that resolution. So we really have, we don't know that happened. We can assume that didn't happen. Well, what about another thing here is we are assuming so far, okay, these are sampled every hour until we get to 6 a.m. Then for some reason, we have an extra sample 9 minutes after the other one. Okay, that's a little weird. And then we do the same thing at 12. It looks like there's an additional check every 6 hours. Okay. So if we were to weight every sample the same, we would actually be slightly inaccurate, because these two here, where we have two samples 9 minutes apart, those should not be weighted as highly as samples an hour apart. So this question of like, is this correct enough? I mean, it probably is enough. Is it exactly correct? Well, there is no exactly perfect answer we can get from well, really from sampling to begin with, but especially a sampling at irregular intervals. I mean, we just have to decide what type of error is acceptable. If we wanted to get like really fancy, we could essentially like, maybe graph all these points and then, what would that be? Maybe some calculus over that line or something like that. I mean, even that still has sampling errors, but that would at least solve the irregular nature of the samplings or the samples. But I mean, the point of this question really isn't that there is a solution here. The point of this question is there really isn't a perfect solution with this irregular data. And in the real world of, whether it's corporate or, weather or science type things like this, you often do not have good data. The data, somebody forgot to run the backup and they accidentally deleted it. So we lost 3 weeks of information of, our 5 years ago sales data. There's 3 weeks missing. The company was just starting and somebody didn't know what they were doing. So there's 3 weeks missing there. And then we changed how we stored stuff 2 years ago. So we now sample stuff at a different rate, or, the actual units we use to measure it changed, or, crazy things like that. So that type stuff will apply a lot if you end up doing like data science stuff. But even just as a developer who might need to make, a report on a dashboard or something, that type stuff really starts to come into play. What is the information we have? I've, talking and reading with like data science people, the stuff on the brochures says they get to do cool data science, well, actually they get to do that like 10% of the time, and 90% of the time is like cleaning data. Because, all the source data is so messed up. You just spend all the time trying to figure out, okay, how do we clean the mess out of here? And how do we determine like, what is this stuff actually? So this is really just an example of that, of, those questions are really hard. And this next query shows us this in even more interesting detail. So we don't even have the same amount of samples every day. For some reason on the 7th, we have 65 samples, whereas on the 1st, we had 27. Who knows why? Maybe we had an eager beaver intern who decided to go out and check the temperature an extra, a few times or something. Who knows? And that type data would, if we were trying to actually get, what is the, average value for something, sampling errors could really mess that up. So one of the things that's valuable in that case is trying to get whoever the stakeholder is, whoever the boss is who said, I need a report of X, is to go back to them sometimes and say, okay, that question is difficult to answer exactly. Could we rephrase the question a little bit? So this question of what is the max and min speed per day? Well, that we can answer more accurately. We still have the problem of if there was a gust of wind that happened outside of our sample, we still could miss things due to sampling errors. But as far as trying to handle what if there was a cluster of samples and then there was a time period where we do not have any, how do we average all that stuff together? This resolves that question. We just say, given our samples, what was the min and max? Well, that's a question we can answer better. And that might just be a better question to answer anyway. All right, let's try one more here, another exercise. Let's do a query that gives us the high and low temperature, high and low humidity, and the high and low wind speed for each day at each station. Now this should, just a hint here, I'll give you about a minute to do it, but I mean, this should be basically the same query. We just add a few more, things to the select. So we basically just add more pairs of min and max functions for the new columns. A few things we might want to do here. One is this query is starting to get really long. It's a little difficult to be manipulating this in the P-School prompts. So what I generally do once the query gets very long at all is I will create a new file I usually just call it t.sql, just the shortest thing I can do for temp. And I move my query there. And one of those backslash commands, \i, and give it a path, and it runs that file, I for input. So then you can use your full VS Code editor or whatever editor you like, and you don't have to, try and do it in that very limited editor that you have in your terminal.
Is there a way to add like labels to the columns?
Yes, that is exactly what we should do next. So SQL does not enforce any particular formatting. When something gets long, I tend to put 1 column per line. But then you can say as, and then say what it is. So, technically the word as is not required, but in this particular case, I like the extra readability.
Yeah, it looks a lot cleaner.
Oh, temp F for temperature Fahrenheit, huh?
Yes. Yeah,
That's
that's
awesome.
another, go ahead.
Just saying that is awesome.
Yeah, that's another thing that whether in SQL or in Python or whatever, when you're naming variables, if possible, or if reasonable, include the unit in the variable name. There was another story. This was probably 10 years ago now, but I believe it was one of the Mars landers that like crashed because one part of the code was using English or imperial units, and one was using metric units, and there wasn't a proper conversion done. They didn't realize they were different. So
I remember that story.
yeah, so that's like a couple $100 million bug there. So yeah, it's generally considered good practice to include the units in your variable name, or at least when there's potential ambiguity.
Sorry, what was the syntax of that? \I and then t.sql?
Yes, so it's \I says import a file and run it, and then you just give it the path to the file. Okay, so the next thing we can do here is we can use a subquery. So we're going to find the monthly average high and low temperatures. So that we kind of can do once we have the min and max for the day. So this entire query here that we just wrote, we are going to use this entire query as a table. So in the from clause, we can put parentheses, and then we can just write an entire select statement. And we have to name it outside of the query there, but then we can refer to it just as if it was another table. So I'm gonna copy and paste this whole thing into t.sql again. And close this down so we can, let's see, I just need to hide that terminal.
I'm sorry, this is one statement.
One statement. And believe it or not, this isn't nearly as long as some SQL statements can be. It's easy to have, I say it's easy. It's quite possible to have like one query that's like hundreds of lines of code. So what we're doing here, well, let's run this and see what happens. Let me get my terminal back here. Where'd terminal go? Let's run this. And need to save that. So the average, we get the average low temperature and the average high temperature for each day, you know, or for the month, you know, on a daily basis. A couple more things that are happening here. This left, the left function we give it a string, we give it the number of characters, it gives us the leftmost ones of them. So this thing here is actually just kind of abusing that to say, give me the leftmost part of the date, and it's using that so we just get the year and month. It's kind of a little trick there. And we are, again, doing this group by stuff to avoid having to retype out all this stuff. Now, this is kind of a long query, you know? It would be nice if we could make this a little cleaner. So look at this. Create view. So we've already talked about creating tables, and we've already run select statements. A view is a way of saving a select statement and letting us refer to this potentially very complex statement as if it was just a table. So if we run this, I'm going to paste this down here. It doesn't actually give us any answers. It just says create view, because all we did here was save this query. So from now on, though, we can just say select star from daily summaries, and we get this data out from there. Then we can use that inside of other queries. So that really long query we just had, now this boils down to that. We get the same answers back. So views aren't something that I use all the time, but on occasion when you have like one complicated query that needs to be used multiple times from multiple places, extracting that into a view can be really convenient. Now it still has to do all the work though. So if we look here, like this query takes a little over 100 milliseconds to run on my computer. We could create a materialized view. So a materialized view is the same thing as a view, except it saves the results. If we run this, we can see that now that query runs in 5 milliseconds instead of 100. But there is a really big problem. It's a lot faster because it pre-computed a lot of the work. So how many of you have heard of the 2 hardest things in computer science? Anybody heard of those?
You can take a stab at it.
Okay.
Does it have to do with kind of similar to the saying in life of like, you can't have all 3 like cheap, fast, and good quality? Is it kind of similar to that, but is it with like scalability, readability, and then I guess like time or something along that lines?
No, this is a different set of the impossible or really hard things. This particular one is the 2 hard things in computer science, or the 2 hardest things, are 1, naming things. You'll probably have already even run into that, but if you haven't, you'll run into that for your whole career. That coming up with the right name for a concept, whether that's a program name, whether that's a function name, whether it's a table, column, variable. Coming up with the right name for a concept can be really, really hard. So naming things is really hard. The second thing that's really, really hard of the top two things is cache invalidation. And that's what we're doing when we're materializing a view. We are caching the results. So caching is easy, but cache invalidation is hard. So for example here, I have, all that data, in those reports. I'm just going to delete it all. Well, can I still run this query? You bet I can, because that materialized view doesn't know that anything has changed. So we still have a snapshot as it was a few minutes ago. If we ran the version of this that is not materialized, then we get no rows. So materialized views are something useful to have in your toolbox, but you'll probably won't use them very often, but it's good to know they're there. There's another command where you tell it refresh the materialized view, where it actually goes through and tries to figure it out. What would make them far more useful is if Postgres could tell something has changed and automatically update itself. And they are working on that. I saw some of the discussions on their developer group. I'm not sure if it's landing in Postgres 14, but if it's not 14, it looks like there'll probably be something that'll land in 15. But no guarantees there, obviously. But oh, and of those really two hard things, like we said, number one is naming things. Number two is cache invalidation. Number three is off by 1 errors. And if you program in C or any language like that, you'll definitely get that one. Let's see here. So we got a couple more exercises and we got about 10 minutes left. I think what I want to do is just jump to the solutions on these and discuss them. And then if we have any time left, there's kind of like a handful of little tricks with the pschool command itself that I'd like to talk about before we go over into the data modeling thing with Jake. So let's open up this solutions SQL file. And let's just look at those 3.1 and 3.2. So this 3.1, the question was, there are many missing, are there any days that are entirely missing? And we talked about cross join, generate series, left join. Okay. Generate series. This is a really useful function. It's a set returning function. We haven't seen any of these yet. So what generate series does is it actually is a function that basically returns a table. So we can do something like this. We tell it the start time or date, the end time or date. We tell it what increments to use. And it generates the series for us. There are variants of this both for time and for numbers. So we could also say something like generate the series between 1 and 40 and increment by 5. Or increment by 2 or whatever. So with that, this lets us build a list of all the days in our data. We cross-join that with statements. So remember, cross-join means give me every possible combination of these. So for every day, we want a row for every station. Now these last two lines are where this gets really interesting. we're going to left join on that daily summaries view. And our condition is going to be the date is the same. And we got this little conversion operator here because generate series actually works on timestamps, not on dates. So D is actually a timestamp at this point. We need to convert it to a date so it's comparable here. But if the date is the same and the station is the same, we match those things together. Now, if you remember, the left join means if there is a match, we include it. If there's not a match, we do not include it. Well, in this case, we're looking for ones that are not included. So we do the left join, and then we look for the nulls. And those are the only ones we care about. So if we run this, we can see that, yeah.
Wait,
Got it?
how do you combine a cross join with a left join?
Oh, that's another new thing we haven't talked about. So you can join more than two tables. You can join any number of tables together. So in this case, you could kind of view it as if we had parentheses around here. So this essentially gets joined into a single table. And then this single table gets left joined with this. So generally your joins will work left to right. I think there actually is an order of operations thing for certain weird joins. But in general, you can just think of it as it goes left to right. So this thing gets joined with this, then the entire result of that gets left joined with this.
What was the syntax for creating that the view called daily summaries?
That was here. It starts on line 69.
Oh, okay, yeah, just create and then whatever as.
Mm-hmm. You can also, for what this is worth, you can also create temporary views and temporary tables for that matter. But if you're just doing some ad hoc reporting, just, that doesn't need to be reproducible, you might just create temporary views for your own use and they'll automatically go away when you disconnect from the database. So yeah, it turns out Jacksonville apparently has a lot of days where they didn't bother to check the weather station. And it looks like Chicago has a couple. So this second one here of what days had the most similar temperatures. Here's another thing that we can do. A couple of new things here, actually. So first of all, notice we're selecting from the same table twice. If we do that, we have to give the table a name or an alias. So we'll say the first time we select from this table, we're going to call it ORD for O'Hare. And which that's an interesting thing too. Why O'Hare has that weird abbreviation or whatever. Is anyone familiar with that? So it used to be something that was like an orchard.
Yeah, a lot of the airport names, like if they have something that doesn't line up with like what the name of it is, it's usually based on like a town or a thing within the town that it's near.
Yeah, it used to be named, Orchard Field or something like that. And it was renamed after a World War II Medal of Honor winner named O'Hare, but they kept the original code.
Midway might be stranger.
Yeah.
So you're naming the tables after referencing the tables.
Yes. So you can you can, if you put another thing here, you can essentially alias a table. Most of the time, you don't need to do that. But in this case, since we're referring to the same table twice, we needed to add a we needed to add an alias so we could tell them apart. So in this case, what we're doing is we're reading from daily summaries. We're going to name this one ORD and we're going to name the other one JAX. Using date is another little bit of shorthand. This is equivalent to that. It's just a little shorter to write. It lets us say, yeah, I'm just going to list columns that have the same names in both tables and they must be equal.
But isn't it the same table?
It is the same table, but we're going to read from it twice. And essentially, we're going to treat it as two different tables as far as the query we're going to run on it. So in this case, what we're doing is we're trying to find when there were similar temperatures. So the first time we're reading from the table, we only want the rows where station ID is this number. And the second time we're reading from the table, we only want the rows where the station is this number. And what we can do here, let's run this and see what comes out. That might make it a little clearer. So if we were to, in fact, actually, I'm gonna change this to star so we can just see what it comes out to start with. So we have, first of all, we have the row from O'Hare. We scroll over, we have the entire row from Jacksonville. So we're getting, we've joined both those rows together based on they have the same date. And what this does when we do this absolute value is we look at what is the overall difference between the dates, between the temperatures. So we can see, no, I didn't save that, sorry. So we can see that, on June 21st of 2012, the temperatures were, the min and max temperatures were exactly the same in both airports.
How are you ordering it?
So order by 6 ascending, that's saying order by the 6th column ascending. The 6th column is this one here, which is the diff. So ascending means our smallest values will come first. So we're ordering by the smallest difference between the cities.
Okay.
And then if there are any that are the same difference, we also order by column 1, which is the date, and we say ascending. So it'll also be the earliest date first. That's why the one in 2012 shows up before the one in 2013.
Oh, okay. So order for that 6 ASC and the 1 ASC matter pretty big.
Yeah. So do we have any questions on that before we're going to spend about another 3 or 4 minutes. There's a few more useful things I want to show before we go to the data modeling thing. But any questions on those?
I feel like I definitely have to practice a lot of the stuff.
Yeah, now those last 2 ones, I mean, even in the lesson, I marked those. Those are pretty advanced stuff. Yeah, so again, don't worry if this fire hose of information is, a little overwhelming. You'll get it with time and practice.
Functionally, when you're working with a lot of this stuff in practice, are you usually inputting a lot of data sets through manually through SQL or whatever the program is, or is it done more in application? Or I'm guessing Django would be kind of the connection point there. How often would we be likely using SQL as inputting a row?
Can I take that one, Jack?
Yeah.
This is a great question, and actually it usually comes up sometime during the day, but we didn't really quite get to it. Yeah, so I think there's two answers to this, right? One is when you're actually changing a database, how do you do that? And the other is, are you typing into a REPL like this much in your career, in your actual job? I think those are two separate questions. I'll try to answer them. So when you're actually changing a production database, there's a process that's very predictable and boring to lead to that happening, and we call it migrating the database. So if you want to change, let's say you wanted to rename a column in your database, you make a file in Python, ORM, or Rails, or SQL, or that renames the column, and then you'd make a companion to that function that renames it back. And then in your local development database, you'd run the function that renames the column, and then you'd run the function that renames it back, and you'd make sure they both work. And then you deploy this code to like a staging environment where the database is like almost exactly the same as production, and you do the same forward and back process. And then after all of that had succeeded and you've done whatever QA testing you want to do, then you deploy to production and you'd run the script to go forward and to rename the column. So as far as this altering tables with your hands typing in a REPL, that's not how it works in production, and it's much safer to do it. I feel the joke coming on. Yes, and then the test email goes out to your customers. In production, it's very boring. You're not actually typing the SQL at all. You're running a script, and you're backing up your database before too. So if somehow your migration really does break everything, you just go back to a previous version of the database. So in one sense, the typing that we're doing right now is not very realistic, because you never want to be in the production database doing update statements. That's a very bad situation for you to be in. But on the other side, I type in stuff into SQL REPL every day, and I think probably Jack does too, because for my work, I'll pull down a copy of the production database and I'll just explore things. I'll be like, okay, if I want to do this migration, how many tables are going to be locked up when I do that? Okay, I'll select and I'll count the records, or how many orphan records are there in this table, in production? And that's where knowing how to type these SQL commands into a REPL are like a superpower, because you want to know that information, and the only way to do it is to know SQL and to be able to type, to actually run the queries. So it's like a mix. You do this somewhat to learn and to try things out and to experiment, but as far as like really changing things, you use migrations.
Yeah, you'd rarely connect directly to the production database and do anything by hand, but you do it all the time in development to figure out what you're going to do. And even like at application land, if you need, this dashboard or some sort of page that's going to have some sort of analytic report or something, well, you would use the SQL prompts to build that up, most likely.
Got it. Thank you.
Cool.
And it never works until the intern sends out the emails.
Poor intern.
Yeah. So the one other thing I wanted to talk about real quick was there's a few things you probably noticed that my P-School prompt looks different. Like for example, when I do a select statement, it tells me how long it took. The way you turn that on is one of those backslash commands, backslash timing. So I just turned it off, just turned it back on. You also probably noticed when the nulls came up that I had a weird like empty set symbol as my null operator. And when you saw a null, it probably was just a blank. So there are a bunch of commands that you can use to customize your SQL prompt. And P-School has a P-School RC file. And anything that's in here, it automatically runs whenever you start P-School. So like in this case, I have it such that if I'm importing a file and I run into an error, well, stop, don't keep going. I want to see how long everything takes, so I turn on timing. I want to use this weird symbol for null, so I turn this on. You probably noticed I have that blue background thing that I can scroll through. I want to use this particular pager instead of less when I have more output than will fit on a particular page. Then use Unicode to draw pretty borders between columns. And this, that interesting thing is what makes it where I can see here, you know, this looks a little different as well, where it tells me, you know, which database am I connected to at which host. And that can be useful. You know, so you have a constant reminder if you are by chance connected to an important database instead of development. So you have a little bit of a reminder not to, you know, delete things or drop tables or whatnot. So that's the little bonus stuff of some P-School customization. Why don't we take a break till 3:20, I guess, and then Jake will lead us through a data modeling exercise.
Awesome, thank you.
Okay. Well, why don't we pick back up? So we're going to do a data modeling exercise, and then that should take about an hour. And at the end of that hour, we'll go into the Q&A. So, yeah, probably a little bit less than an hour. We're going to try to end at 4:30 Central Time. Okay, so let me share my screen. So I think Jack and I have taken a really, a very hands-on typing in the REPL approach to SQL, and I hopefully the last question kind of clarified why we think that's a really good way to learn and to just kind of always be leveling up at SQL. But there's another element to this, which is how do you use this information practically to build applications. And so that's kind of what I want to cover for the next 45 minutes or so, is how would you take what we've learned and apply it in your projects. At the end of the cohort will be opportunities to do that. So what I want to do for this exercise is look at an actual website that Jack and I helped build called PGCasts, which is a series of Postgres screencasts. And we made a lot of these a long time ago, and they're all still here on the internet. So basically, PGCast is a website with Postgres information. So you kind of have this featured video up here at the top, and then you have all these other videos that go back towards the beginning. When you click on one of them, you see a video that we made, and you see some information about the number of the video, the person who made it, some tags, and then we have a full transcript of the video with all the code. And yeah, so that's basically the whole site. It's a pretty simple site, but the way we built this was we did something called Storycarding. Let's see a comment, but I'm not. Yes, transcripts. So have you all covered storycarding at all, or that idea? Okay, so storycarding is in HashRocket, it was informed by this idea called behavior-driven development, which is that you describe what you want the application to be from the perspective of a user, and each little group of behavior is called a story or a feature. So when we built this application, we actually, we made a file with these stories. So here's an example of a story type feature. And then you have a name. Visitor views the most recent cast. That was the term we used to describe the screencast. And then description. So it uses a syntax called given, when, then, which is, some people call this behavior-driven development, or Gherkin syntax is a name for this. It's associated with a popular Ruby library called Cucumber, but it predates that. So given something, when something else, then the thing that I want to happen. And the word "and" is also available in there as a, as a extra connector for things. So you basically want to make this like a readable statement. Given I'm a visitor, when I land on the PGCast site, then I am presented with the most recent cast. And for the cast, I see cast image, title, author, and description. So when we would do a project at HashRocket, we would sit down, and for like 2 to 3 days, we'd go and we'd just write these out. We'd write out everything that we thought the user would want to do on the site, or the administrators or whatever. And we get to the bottom of a list. So, there's like 15 of them in here. And when you're done, that's like the MVP of the application. Or if it's a big application, it's like an epic worth of work, something that would take like two or 3 months maybe to do. So that's story carding. I think it's a great way to build something when you don't really know what you want. And it's a great way to break up work into little pieces so that everyone is really feeling like they understand what it takes to get the application built. So from here, where would you go next? Well, there's kind of two schools of thought on this. One is that you want to build the story and then let that drive your data design. So just build this thing and then make the tables you need to make this happen, and then deliver this and then move on to the next. That works really well. A lot of people describe that process as agile. It works really well because you can just stop right here and you have still built something that's useful, and you didn't add anything you didn't need. So that's kind of how HashRocket worked a lot of the time, but sometimes we do something called data modeling, which is we'd actually sit down and try to figure out the entire structure of the database given what we know up to this point. And we know like 15 or 20 stories worth of things. For this app, we know it was really simple. So this is basically going to be the whole application. And we can actually figure out the database from the start. And Jack and I did this a bunch of times. It's a good exercise, and however you choose to do, your solo and group project is up to you. But it's a good process to go through and just do the data modeling first sometimes to think about how databases should be set up. So that's what we're going to do here for the next 30 or so minutes. So I'll use a whiteboard online. So here I've got this whimsical board, and I've copied over the stories to this big rectangle on the side. Can everyone see this okay?
Yeah, yep.
Cool. Okay, so here's all the stories are copied over here, and we're gonna go through each one and then move down the list. So let's say we're working on this and we get to this first story. Visitor views the most recent cast. Okay, so a way to data model this would be like to just go through the sentences and try to anticipate the data model that you would need. So the first sentence, given I am a visitor. Does this sentence imply any tables in the database?
Visitor?
User table.
Well, if you're not storing user information, then no.
Could be. It could be, yes, you could have a table called visitor, you could have a table called user, or you could not. I'd like to introduce an acronym you may have heard called YAGNI. You aren't going to need it. A core idea of software design is like, don't add something until you're sure that you need it. And I would say up till this point, are we sure that we need a table recording information about a user?
No.
No, we don't know anything about them. I mean, you're a visitor when you visit CNN.com. You might not be logged in, but we don't have a definite need for a database even yet. Okay, so moving on to the next sentence. When I land on the PGCast site, let's just assume you bought the domain pgcast.com and you have a blank HTML page on it. There's no real need for a database here either, I wouldn't say. Does that everyone agree? This could just be an empty website. We'll move down to the next sentence. Then I am presented with the most recent cast. Okay, so now we have a thing. We have something. Cast was the term we used for these screencasts. Okay, so I think we're getting this. This might be something coming from a database, right? But let's kind of follow that assumption and go and keep going. So let's make a table and give it a name. What's the name of this table be?
Casts.
Yeah, that's a solid answer. Anybody have a different choice? Well,
Stone, so that'll work for now.
yeah, it'll work for now. It's probably good enough. We try to keep this idea in mind called domain-driven design, which I'm really big on. I don't know how Jack feels about, but domain-driven design is basically like make the application mirror the domain that you're working in, and I would say that we call these screencasts or cast, and everyone who comes here would think of them as cast, if it perhaps. So I think cast is a pretty good name. Okay, so I'm presented with the most recent cast. Most recent. Well, what does that mean? How can something be the most recent?
So newest creation date.
Interesting. Okay, creation date. I don't know what Django ORM calls these, but in Rails, it's called created at is the kind of conventional name. Actually, yeah, that's a Rails thing, created at. In Phoenix, it would be inserted at. Let's just go with created at. That's one way to do it. So what is created at? What kind of type is it?
Would it be a date type?
Okay. Yeah, I think one thing that could be is a timestamp or a timestamp with time zone, as Jack would advocate for. Just so since we're going through this exercise fully, can that be null?
No, if it's created, it has to have a date in order for us to always be able to pull most recent.
Yeah, this is a great concept of a column that really shouldn't be null, I don't think. If it exists, it was created. And you could say default now is a Postgres function, I think. So it's created at, it's a timestamp with time zone, it's not nullable, and it defaults to now. Usually your ORM handles setting this, and usually your ORM won't let it be null, but we like to codify these rules in the database, so we decided to go the extra mile. Okay, so the most recent cast. What does recent mean? Does that mean does that mean when it was created in the database, or does that mean something else?
Or there's nothing that supersedes the date of creation.
Like its publish date, maybe?
Interesting. Here's a thought experiment for you. I create this application and I have 50 screencasts that I want to start off in the database with because I already have done them and they're all ready to go. 50 is a lot. Let's say 5. When I decide to run a script that puts them all into the database. The created at date for those is going to be all within like a millisecond of each other. I created them all today at 9 a.m. and they're all, and I actually I might not even be able to say for sure which got created first. They all got, I did it in a transaction or something, and it's not deterministic. So they're just all within like a millisecond of each other. Would that support the concept of the most recent?
We need a scheduled date time.
Yeah, okay. Scheduled. Yeah, you could do like schedule that. I think for I think another way to do it is like publish that. A lot of times sites will have like a publish that, which gives us that like idea we talked about earlier of it kind of serves as a Boolean and as a timestamp, right? If it was never published, then there's no timestamp, and there could be screencasts that never get published. I think schedule that is fine. So we'll keep created at because that's just part of the database anyway, but we can kind of skip that going forward. So this could be a timestamp. This maybe, well, if you're using schedule that, I guess it probably can't be null, right? Because everything gets scheduled.
I think you could have it in your database and not have it scheduled. It's a feature.
Okay. Well, yeah, but I mean, if you, yeah, that's true. That's true. It could be something in the future could be scheduled too. But I hear what you're saying.
Could still be a draft and not not scheduled for publishing yet because it's not done yet.
That's great. That's totally true, Jack. Right. So if you ever use like a editor that has a drafts feature, a lot of times this is how they'll do it, is they'll just have schedule that means that it's not a draft anymore. So let's say schedule that. So, then when you're iterating over these, if schedule that is in the past, then that means that it's released. And then the most recent is the most recent one. So I think
one whose time has passed.
What's that?
If it's scheduled app, some of those dates are future, so it could be the most recent.
Yeah, so I think that's the downside of using schedule that, is that you have to do some work with the timestamps to only show the ones that are scheduled at in the past, which is more code. If you do publish that, then yeah, I mean, either way, you're like making an assumption, right? Can something be published at in the future? I don't know. I would say yes. I would build an app where something could be published at in the future, and then I would check to see if the published at date is in the future, and if it's in the future, you wouldn't see it.
If you called it published time instead of at, that would lend itself more to future or past.
Sure.
There's like English,
Yeah, sure. I like the idea of published time being in the future, because then you don't have to do, well, I mean, you can deploy, and depending on when they view it, the screencast becomes available or is hidden. Jack talked about naming and how complicated it is. This is what he's talking about. It's like, what's the name? What does it mean? Will everybody understand it? This is like the level of detail that you kind of have to go into when you're building a database.
I think I'd have a status that decides if it's imagined or something that's in process or something that was ready to publish or something that has been published.
Yeah, a common solution for that is something called a state machine, where you can say the cast has a status, and then usually you can build it in the database, or you can use a library where it enforces that status is like unpublished. I can't type very well today. Unpublished, published, deleted, maybe draft. And then these types of libraries usually give you functions like publish, which will move, you say you make a set of rules and you say, when I call publish on it, then it moves it from unpublished to published, or from draft to published, or like delete, it moves from any state to deleted. State machines are controversial, I would say, because they can add complexity to the application, right? Like if you add a state machine like this, then you had better get rid of this column, because you don't want to be in a situation where the published time is yesterday, but the state of the cast is draft. That would be weird, but it's easy to do that when you bring in a state machine. So some people say, or an idea is that state should reflect things like this. It shouldn't be its own thing. I know, Jack, do you have state machine opinions?
So, well, to me, the thing here isn't so much if this is a state machine versus just if we have the column or not. Because like, to me, the state machine stuff is a system where there are only certain possible transitions.
Sure.
If this is just a status column that can be arbitrarily set to any particular one, then, we still have the issue of status, and, we have two columns that potentially can represent conflicting ideas. Is the problem there. But the state machine part is, I think that's kind of ancillary, whether you use one or not.
Sure. Let's keep going and see what the rest of the story tells us. So we could, with published time, you could represent the most recent cast, right? Because you'd know what's the most recent published time, and that would be what you'd show. Plenty of other ways to do it too. Okay, so then for the cast, I see a cast image. Okay, so we need a new column. What should we? And that cast image is like this thing here, which they all happen to be the same right now, but they used to be pictures of all of us are us talking in front of a brick wall. So what would we call this column, this image?
A thumbnail?
Sure. That's one thing you could do for sure.
An elephant nail.
An elephant nail? I haven't heard that.
I mean, it's an elephant.
Oh, sure. Well, they all look the same, but they're all different because they have, the title isn't like being programmatically generated. Like somebody made this image in Photoshop and like uploaded it to YouTube. So, but let's forget about the YouTube portion and just imagine that each one of these needs to be a different image. So thumbnail, I think, is okay. What's the type of this column?
It's probably a separate table, or is this you're probably not going to need a problem, but like wouldn't thumbnail be its own table because you're going to manage that separately from casts where they're just interrelated with foreign keys?
You certainly could do that. A very common thing to do, a very common web development approach is to not try to save the images yourself. So you could do another table. I think if all we were ever going to do is this story and stop, if we're like following the agile mentality, one thing we could do is we could just do like a thumbnail URL or an image URL, and then this is just a string of our character varying, and this is pointing to someplace else where the URLs are stored, and that gives you some performance benefits where you can like put the image on something like S3 and then put a content distribution network in front of it so that the people are getting the image from a server that's very close to them instead of like your Heroku server, in Virginia or whatever. So that's an approach. And I'm going to just push for that because I want to keep us on this track of like, sticking with the least amount of stuff going forward. But yes, you could totally do that.
And you need the same thing for the cast itself?
Say again?
You need the same thing for the cast itself?
Well, this table is going to represent the cast.
I think you might mean like the video.
Oh, sure. Yeah, great point. So far we haven't gotten to that yet, but I see that coming for sure. Can this be null?
If it's null, you end up with an elephant image.
Yeah, that's a good call. I mean, you could say null is true maybe, and then in your Python code, if this isn't set, then you have a default image that always shows. I think that's fair. Okay, so that gives us the image. Title. Okay, so how about a column called title? And this can be a string too, or character varying. Can this be null?
I mean, it depends. Yeah, let's say you want to know what you're looking at, so I would assume no. Yeah,
I think a good posture on null is like make yourself really argue for something being null. You have to make a good case for something being null, and I can't come up with a good case for why title would be null. Like, I just want it to be null sometimes, so I don't have to set it. But the downside is that you could have a bunch of. Then if you don't require it, then everywhere you show it, you have to be able to handle that. So if you don't make the person who's entering this data? It's us. It's an administrator, right? It's an employee of your company who's filling out the form or whatever that makes this a thing. So you can either do the work in two places. You can make the person filling out the form put in the title, or you can make your view be able to handle not having a title. Right? Like if this is null, what is here? I think it's, in this case, I think it's easier to make myself who's filling out the form to populate this have to put in the title than it is to have the view be able to like do something with no title. Trade-offs. Okay. Title, character varying, null. I'm gonna say null false. Yeah. Okay. And you could put some validations on there too. Maybe it's limited in how long it can be. You could do that in Django ORM. And then we have a description. String or varchar, I guess. Maybe this can be null. We'll like be chill one time, and maybe this can be null. And then your view, just if there's nothing here, it says like some default text or something.
You're always going to get it done in 255 characters.
Say it again.
Are you always going to be able to describe it in 255 characters?
That's a great point. I would probably put a constraint on this field because I don't want somebody to be able to put like a giant novel here, because it's eventually all going to have to fit into this like little rectangle. And the point of it is the description is not actually a very good name. It's more of a summary. I would call it a summary. And that's, I think, a case of our name that we chose when we story carded this not really describing what we wanted. It's not a description in the sense that it's like, well, what is it? It's like, it's a little blurb that like you use to describe it. And this all gets put into meta tags. So I think there's a meta tag somewhere on this page where this, this hey everyone copy is included somewhere in the head, right? Yeah, meta content. Okay, well, maybe it isn't, but it should be. And so we want to actually limit how long it is, because for SEO, you don't want that to be too terribly long, but you wouldn't even really know that reading the story because we didn't think of it that way maybe. So maybe description isn't the right name, maybe summary or like SEO description, I don't know. Yeah, we want to force people. I think we want to force people to be able to write something short about it. It's like, you know, restrictions are okay. It's okay to restrict users as long as you tell them that they're being restricted and they understand how to, you know, submit the form so it will save. I think. Is that kind of what you had in mind?
Yeah, it's fine if that's the plan.
Yeah, it's all up to us. This is the process, really. If you really went into story carding, like maybe 3 or 4 stories down, we'll find something about this, you know, the length of that subject, or it maybe just no one thought about it. Okay, so we've gotten through one story, and we have a table that supports that story.
You're gonna make the author feel bad.
Yeah. So that I missed the author. Okay. So we need some way to represent the author. What are our choices there?
I think you go to the author table.
Okay. Another table. That is definitely a choice. Does anyone want to, what would be the benefit of doing that?
Well, you don't think the author's going to stick with just one story, do you?
Good point. Yeah. If you, so the cheap and probably the fast and cheap thing to do would be like to put a column in called author name or something. And that's a string, and it's null, it's not nullable. And I don't think that's a great solution, but it's something you could do. The problem with this is then you're basically, you know, when I fill it out and I've written something in here, I have to say, you know, Jake. And when Jack fills it out and he's made a screencast, he has to say Jack. And the next time he does it, he might type in Jack, and there's nothing stopping that from happening, right? I mean, you can do like a validation where you say the string has to match one of 4 or 5 different strings, but it's not that's not data integrity really. It's kind of just, it's like a hack. So
Delaying the inevitable.
you are kind of delaying the inevitable, but it might actually be okay. Let's look at PGCast for a second and see. So we built this and shipped it. Let's see, did we ever do anything with the authors? What if I click on this?
I think you did. Or it's just a link.
It's just a yeah, it's just a link. So this is Mary, and it linked to her developer page on hashrocket.com. So we never actually built anything that collected. We never actually built anything that collected all of Mary's posts in some place, which would have been cool. But on the other hand, this, looking forward a little bit, this goes somewhere and it has information about Mary. So it has her name and it has a link to her HashRocket page. So if I saw this in the design, maybe let's say like we have a designer and they made this design and they like indicated when you click on this, you're going to go to hashrocket.com. Then it's like, okay, we probably do need a table because I don't want to do author name and then author URL, right? I don't want to do that every single time I make a record. I don't want to duplicate that information, and I don't want it to be wrong. And if I do it this way, I'm going to duplicate it and I'm going to do it wrong. So this might be
question.
Yeah.
Is the consideration here just like how often you're going to be using author and for what in terms of like design of the broader site? Like,
yeah, so that is I think that's a really good question. That's like hinting at what I'm trying to demonstrate right now. There's multiple things to think about here. One is that we don't really know what author is going to be used for. So we kind of glimpsed into the future by looking at this website and knowing, but imagine this website didn't exist. What is author actually going to be? It might be there might be a page for Mary that collects all of her screencasts. You know, it might be her name and a link to an external website. Or it might never be more than a string. It might just be the string Jake. And so you don't really know. You don't really know right now which one of those it's going to be. All you can really do is try to make a good decision. I don't have like the perfect answer because I think that I can make an argument for all 3 of those decisions. But the agile way to do it would be to just say, this is all we know. This is the whole world. And in this world, all that we know is that a screencast has a name on it. So, the agile, and again, I'm not saying this is the best way to do it, but the agile answer would be to just put a string with the author name and move on. And then what's likely going to happen is you're going to get farther down and you're going to see, oh, when I click on that name, I go to their page on hashrocket.com. And then this wasn't enough. But if that story never exists, or if your client doesn't want that, or if you're a contractor and you get taken off the project, this ended up being enough, and this is all you ever needed. Does that like
your authors are submitting things and they get credit for how many views that they get and that kind of stuff?
Exactly. That's a great argument for doing a table, is you need to collect a bunch of information about the author. My point that I'm trying to make is that right now we don't know that. So it's a theory in software is that it's bad. Complexity is bad. So building things that you don't need. Every line of code you add is a line of code you have to maintain. Every table you add is a table you have to maintain. Anything you build is going to be future work for somebody to maintain it. So if you don't know that you need something, there's an argument that you should not make it, even if you have an inkling that you will need it. Anyone, does that make sense, or do I need to make more cases?
That's kind of like you were saying earlier, or I think it was Jack that said earlier. Be patient on like deciding what your design is going to be. So basically, don't make anything until you absolutely need it.
Yeah, exactly. Extra code is the bane of your existence, because every line you write you have to maintain. Every table you add you have to maintain. It's more the simplest design is always the best. The simplest design that accomplishes what you want to accomplish is always the best. And right now, if this is all the application ever was, this is probably the better design, because it doesn't, it fulfills what the customer wanted, and it doesn't add any, it's just one table. I think we know from looking at the website that this wasn't the final architecture, but it works for this story. Let's keep going and see how our design scales. Okay, so next up, visitor views list of recent casts. So given I'm a visitor viewing the homepage for PG casts, when there are recent casts, okay, we have a cast table already. Then I see n number of recent videos as dictated by design. Whatever, they want to show 5 of them. And the videos are sorted in descending order by date. Okay, good. We did publish that, so we can do that. And for each video, I see thumbnail, which we have, title, we have an author. Okay, so this is just another way of showing what we've already built. But the cool thing is that because we thought through it all on the first story, this is just basically a front end story where you're making a view and a controller that like load up this data for a different route.
And up to n videos is one visit. Is that it?
I'm sorry, I think my audio cut out there. Can you say again?
I have audio issues. The up to n views is in one visit.
Like counting the views?
Yeah, there was a thing about I see up to n.
Yeah, let me I think what the actual, I probably am moving a little quickly here because I'm very familiar with these stories. What we wrote was, then I see up to n number of recent videos. So we didn't know what the website was going to look like at that point, and we thought maybe we'll only show like 10 screencasts on the main page. We ended up showing them all, but the design was going to have like 10 of them. So that was what I was trying to talk about, was I see like 10 videos.
Okay, that's what he's seeing. I thought it meant he was viewing up to some number and then you stopped him.
Yeah, totally. Yeah, this is like some hasty software building back in the day. A lot of times you get these stories, you wrote them and then like you look at them 3 weeks later and you're like, what were we even talking about? And that's part of the fun and the challenge.
It's perfect. Before you showed it to us, it wouldn't have nearly the value.
Yeah. Okay, next up, visitor views the show page for a cast. So this is a time-honored thing in software where you're actually showing like one resource. So given I'm a visitor viewing the landing page for a cast, we didn't know our terminology very well. This is the show page for a cast. Oh, no, the landing page is like the landing page for the whole website. So we already built all this in our first story. When I click on a cast, then I am taken to the show page for that cast. Okay, so this kind of implies that there's some way to identify an individual screencast. In Postgres, you put an ID, an incrementing ID column in there that would handle that. So we don't usually even include that stuff in these records because it's so common that it's just like it's a bit cluttering to describe that, but you're going to need that now. And for the cast, I see, okay, a video player, a title, an author, description, and a tag list. Okay, so what's the video player? How's that going to work?
I would guess similar to the image.
Yeah, that's what we did because it's really easy. Is we did video URL, and it can't be null because that's the whole point of the website. Maybe not, but just gonna be uptight and say it can't be null, and it's on YouTube. And then the nice thing about that is, it's all managed there. It's all hosted there. The downside is we don't really kind of control over it there. So that was a choice that we made. But that gets us up to the last line of the story. We need a tag list. Okay, what is a tag list? Well, we had this idea that we were going to tag stories, tag these screencasts, but we only ever made one tag, which was Postgres version 11, because this was before Postgres. This was when Postgres version 11 was brand new, and we wanted to showcase that we were writing about the most recent version of Postgres. But let's forget that we only ever made one of these, and let's imagine we have no idea what this even is going to be. How could we represent the tags?
Some of the stuff Jake's mentioning here, it's great examples of that. You ain't going to need it. We had things and then oh, we never really used that.
Yeah, right. So this is excellent point. So here's the example of you aren't going to need it, illustrated. Let's say we saw this story and we're like, okay, we need tags. We will do a table, and it's called tags, and the tag will have a name. And of course, that's not nullable. And maybe we'll have a description in there too, so that when we're reading the code, we know what the tag means, or when it's exposed through an admin panel. And then we create a relationship between these two tables. We say a cast can have many tags, right? So you say tag Postgres 11, what are your casts? And it gives you 15 screencasts that are all tagged that thing. And you do it the other way. You say screencast number 1, what are your tags? And it's Postgres 11, Postgres 12, Postgres 13. This isn't wrong. And if you're getting into relational databases, I would say, try a design out like this and run with it. It's totally, this is what relational databases do. And there's nothing wrong with doing this. But in the case of this application that we built, if we had done that, I would say that probably would have been a mistake, because we only ever did one tag. So you put a table in the database, and you made a has one belongs to many relationship just for one record. We didn't know that, but the cheap thing you could do is you could say tags, and this is an array maybe, and then you say Postgres 11, pSQL. And is this wrong? I don't know. It's hard to tell. All these tags do so far is they just show in a list. They're just down here one after another. You say tags dot each, and then you have a little piece of HTML that renders them, and you don't know, but you don't know if that's enough quite yet, because it might be enough. Or you might want to click on these and show all of the screencasts that are associated with them. And then it's really important that they all match and that they all, have associations. Does that trade-off make sense?
Yes, you could also, I guess, consider them whenever you're just searching for keywords almost, instead of just clicking them.
Yeah, that's a good point. So for my personal blog, I have tags, but all they are is just text. And the reason I do that is because I just want to tell people when they're looking at the blog post what it's about. And it does put the word Postgres into the HTML. And I could put, if I wanted to, I could put that into like the meta tags and it make my post maybe a little more searchable for Postgres content. So for my personal blog, a bunch of strings is fine. I don't need more than that. And I would rather not maintain a whole system where I've got like a whole bunch of tags that are associated with a whole bunch of posts. So following Yagni, why don't we just have it be an array with some strings in it? And maybe these are all lowercase too. And we capitalize them when we want to based off of like our own choices. It's just data, that way we're not like dealing with one post where someone typed this and another post where someone types that, and it makes everything look kind of, maybe these just get turned into like hashtags. And that's good enough.
Yeah, and one of the things Jake said there about we'll just make it an array, we didn't talk about that type, but Postgres actually has array types. So we can have a column that is an array of text.
Yep.
And Postgres actually has type support for that. It's not just that we mashed it into a single text column and then split on comma or something like that. We can use a real array type. And it has enough like index options and search options within arrays. We actually could go a long way with just having an array.
You could. This is so. I think one of my points for this whole like exercise is that this is not wrong and it's not necessarily right. All it is like a decision that you can make with what you know right now. And if you're choosing between a simple system or a complicated system and both of them work, like I would suggest be on the side of the simple system, because that is that's you'll thank yourself later. It's easier for your team to maintain a simpler system, and this is a simpler system than having another table, I think, for what we know right now. Okay, we're gonna roll into Q&A, but I just want to take a quick break. Let's meet back up at 1/4 and we'll do like 15 minutes of Q&A. All right. I know some people are still coming back, but why don't we get started on Q&A so that we can make the most of the time. I'm leaving at past. I've got a hard stop. Yeah, so Jack and I been doing this a long time. Jack a lot longer than me. We've been consulting. We've been in the Chicago tech scene for a long time. I'm a veteran. What questions can we answer for you all?
So I guess this is kind of personal question, but for the database, because you mentioned data science and data analysis a little bit, working with like specific SQL, say you're working specifically with the databases, what's the line between that and data science? It seems like there's a lot of crisscross.
Yeah, I think of data scientists as people who they use data and SQL as a means to like have insights, and I see programmers more as like using data to build products. I don't know. That's like, I'm not a data scientist, so that's like my best guess at it. But I feel like data scientists are really like researchers who their understanding of data is it's in a different way where they're using it to like understand things. They're more like scientists, and I feel like, I mean, the scientist is in the title, and I feel like programming is more, I think of myself more as a builder, like more of an architect.
Yeah, I think what you actually do, there's a lot of overlap. I mean, honestly, there's a lot of overlap between business analyst and data scientist. It's just data scientist sounds a lot cooler than somebody who spends 80% of their day in Excel cleaning up data. Hopefully gets paid more too. But what I would see as the key differentiator is, what is your deliverable product? As a developer, our deliverable product is software. As an analyst, data scientist, whatever, your deliverable product is, like Jake was saying, insights, information. You know, you discovered something about your customers or something like that.
Totally.
Thank you.
I have a general question about database design or database table design. I assume a lot of it's just like intuition and maybe it's common sense, but like, let's say I'm designing a table to track the names of every person that lives in the United States. So I assume I would have, a primary key, first name, last name, and whatever other information. Like, just considering the US, like there's probably a lot of people with the same last name, like, Smith is a popular last name, and also first name, like, Mike or, Jack is probably a popular. We have 2 Jacks in our Zoom room. At that point, like intuitively, I would just have a first name and last name column. But if you think about that, you're going to have repeated data. Would there be any logic to like creating a separate last name table and a first name table, and then having, foreign keys in my main user table just because to save data? Or is that actually going to not really save data because I'm going to have foreign keys in multiple tables? Like, where's that cut off? Or like, how would you use your experience to say, hey, that's probably unnecessary, or yeah, that makes sense?
I would definitely not do extra tables there.
Yeah, I mean, I would agree. Like if I was going to use a table, but is there any reason, like, how do you go about making that decision? Like, again, you would probably have a lot of, duplicate data in terms of last name and first name, but obviously it makes your tables less readable. So how do you make that decision, I guess?
So from the data modeling point of view, if we extracted last name into its own table, would there be any other columns in that table?
Likely no. Yeah.
That would be an indicator to me that there's nothing else that would go along with it.
Gotcha. Okay.
Yeah, names are an interesting subject because it used to be that like you had a first name column and a last name column, and they're both required, and I think as people write software for more of the world, they realize it like doesn't always work that way. So modeling the names, I think, could be a tricky thing, but I would probably just, I would probably have a first name and a last name and a middle name and a second middle name. I probably would just have a column for every possible name that somebody could have, and just hope that my system supported all the possible names that there could be. But in the end, the names to me are just, the person's name is whatever they say their name is, and it's like, some people say that their name is one word and they haven't had it legally changed to be that. So, you can't really, if you just want to record the information, you have to support that.
Yeah, an alternative that I've observed or I've heard of for international stuff like that is you actually just have a single text column for name. And then you have another text column for, I'm trying to think what's the exact phrasing for it, but like how you address them, what we would say a first name or a nickname or something like that, so what do we call you? And then like, what is your complete name? And the complete name is just a text field. So if it's a single word, it's fine. If it's first name, it's last name. If it's, some cultures have like, they have like family name after family name. So it just kind of like accumulates. So they might have 5 or 6 names and that's their real name. And you just have, address them as X and Y is their entire, like legal name.
I think a lot of applications kind of punt on that whole problem by just being like, well, your email is your name. Your email is unique and that's what we're going to call you. You're going to call you your email. And if you
that's
get
a good point. You could just never rely on name being unique.
But yeah, good questions.
What was probably the weirdest structure you ever had to do, like ever, since you've been doing this?
Weirdest or hardest?
Either or.
So I'm going to say probably the hardest is when you're building a database in a database. So where your data structure that you're supposed to account for is like entirely user changeable.
Oof.
So it's something like they essentially can construct their own data types. So you have to represent types of data as, like tables and stuff like that. That always ends up being really messy. Like imagine if you were building, I don't know. Well, imagine if you were building a tool like Microsoft Access, for example, where they can design their own data types, and you had to do that with Postgres as the backend, but you weren't actually doing create tables. It's just all the stuff they were going to do needed to be represented somehow inside of that one table structure that can represent all those things. I would say whenever I've had to do something like that, unfortunately, I've never had to do something quite as expensive as Access, but whenever I've had to go down that path, that's always really messy.
Yeah, I think Jack's stories are going to be better than mine. Anytime I'm like moving away from an ORM and I'm doing things that are really hyper specific to a database, I'm always like, oh, this is cool and this is challenging and this is hard. It's easy to do the Rails thing or the Django ORM thing. It doesn't mean it's the best way, but those are patterns that are like really simply documented and explained. When you're doing stuff that's a lot more complicated, it's like, you have to know what you're doing and like really think it through. And I love those challenges, but they're always like challenging.
So I have a question. What other forms of data encoding have you learned to help you build databases?
What do you mean by like data encoding?
So like music, Braille,
Oh.
Morse. So using those concepts, but still make a database with those, because I know you can. I just don't know how to do it, but it would make sense.
Hmm.
I don't have much experience to offer there. Most every database I've done pretty much has been just strings in English. I don't even really know. It sounds interesting, Jack.
So let me make sure I understand this. So you're talking about like, what if you needed to store that type information? Or
Yes, but just as a conceptual thought problem, because I've heard you guys ask, this is a thought experiment. So I'm asking you a thought experiment question.
right. I guess I'm still not quite totally understanding the question. I mean, can you make it a little more concrete, like an example?
Not right now. I'd have to think about a little more and then get back with you, because I know what you're asking now, but I didn't think that too far ahead with the question. So I purposely made it broad so that it would provoke thought.
Sure. Well, I guess I'm not sure if I'm understanding that it's like just a different domain that you're storing in a database, or if you're saying that thinking about music helps you think about a database or something like that. I'm not following exactly the question.
I guess kind of like that, because some people think in different ways, and that's helps them navigate life. Because I've seen people do it and they've told me, they're like, hey, this is how I think. So
yeah, I guess that would tend to be like very like personal to how different people see things. I mean, at this point, I almost just kind of think in databases. So
oh, okay, then maybe.
I mean,
okay.
maybe 20 years ago, I might have been able to give you an answer to that, but at this point, my brain's kind of broken or bent.
Oh, okay, never mind.
Sorry.
That's fine.
In terms of starting a career in like working with databases, obviously, or this course built towards Postgres, it seems like a pretty solid tool. Would there be like any reason that would make you consider like learning a different tool, like going into like cloud, like Amazon, RDS kind of stuff, or no? Is it like basically all the same, just learn the concepts and you can apply?
Yeah, I think each technology exists to solve like some kind of problem, and if it's popular enough that you've heard of it, then it has a reason, to exist. So learning different database technologies for its own sake has never been like my particular cup of tea, but like what I do find really interesting is being like, okay, I want to build this type of app, and it's like, how can I support that? I had a friend who built an app that was supported by instead of a database, it was supported by an Airtable spreadsheet, and it's like he wanted to keep something really, really simple, and he didn't even want to deal with a database. So those serverless like spreadsheet type of solutions can actually do that. And so he learned how to do it just so he could build that app. So I always find like follow your curiosity, like if you're interested in something and you want to like learn it, like figure out what it exists for and then try to build something that does that. That's how I learn best.
Yeah, my rule of thumb for like choosing technologies there is one, just basically always start with Postgres, and when it breaks or when it gets close to breaking, you need to try something else, but it probably won't break. And the general scale there is, the exception is when you have a bigger problem set that can fit on one computer. Postgres is still designed generally for single node. You can do replication, so you can do like read scaling. But if you have something where, your data set is going to be, in the petabyte scale, well, Postgres is not what you should be looking for there, most likely. Right. And if you need to support, 1 million simultaneous clients that are all going to be writing at the same time, then Postgres is probably not your solution either. But if you're looking at, the, multi-terabyte scale, the tens of terabyte scale even, and you're looking at, say, less than 10,000 writes per second, if that's like your expected scale, then start with Postgres and you probably will finish with Postgres too.
Yeah, that's a great point. Like the very specific Amazon databases that exist, like Redshift and Glacier and stuff, they have a specific reason for existing, and go out and learn them if you're interested in them, and try to find a job that does them, and that could be awesome. But like if you're just building a hobby app or you're building a demo app for demo day, I wouldn't use Redshift unless I had a really, really good reason to do it, because it's going to be harder and you're going to have to learn more, and you're kind of like misusing the technology to like it's just kind of a distraction for you at that point. Like you can do, unless you have a problem that really needs that, you can do whatever you need to do in a relational database like Postgres.
Yeah, and a lot of these big tools, they were designed by companies that had really big problems. But a lot of those problems, the solutions to their problems are actually our problems if we're working at a smaller scale. So it's like, if I want to go across the street, what do I need to do that? I need a pair of sandals. If it's a little ways down the street, maybe I need a bicycle. I don't need a jet aircraft. So a lot of these things in many businesses, if you work for Google, maybe this isn't the case, or Facebook or something like that, but if you work for your average small mid-sized business, chances are they need a lot more of bicycle solutions than they do of jet engine, jet plane solutions. And bringing in Google scale solutions to problems that could fit on a single computer is just making everybody's life harder.
Got a question for those of us that enjoy more of the back end and database type stuff. Do you have any suggestions for learning material other than the manga for databases? And then also, like, with us looking, and I'm saying like I bought that, I'm looking forward to reading it, but and then going into the job market too, any suggestions for like good foot in the door for this kind of specific stuff?
So for learning resources, the official docs are really, really good. If you're a person that can learn by reading, I know some people, they like, watching videos or different things, but if you can learn by reading, they pretty much detail just about everything there is. I mean, it is like literally thousands of pages, but they cover everything pretty well. As far as the foot in the door goes, I guess your options there are probably a really small company where you're the guy or girl or whatever who does everything, and that lets you learn by doing. Or yeah, you'd have to get some sort of pretty junior position there, because being in charge of the data integrity of an organization is, a pretty big deal. So you'd probably have to aim for like a pretty big company at that point, be my guess. But no,
Yeah,
actually, yeah. I came at it more from the developer side, so I never went in directly into data stuff. So I'm not totally sure there.
Even small migrations, like when you're starting out at a company, though, you can like use those as opportunities to flex like what you've learned about Postgres, because a lot of times people will just be like, well, this is a table, and so we're going to index it on IDs or something, and you can say, oh, I've learned about partial indexes, and I know that a lot of these don't have this ID, so let's do a partial index here and it'll be a lot faster. And then you can like do a little demo where you demonstrate how much faster. I think even like the smallest of SQL work is an opportunity to like try out stuff and be creative, because most developers, I would say a lot of developers aren't really interested in the data layer, so they're just kind of like, well, I'll let the ORM handle it, and you can set yourself apart by just caring about it. Okay, I think I have time for one more question.
I'm curious about what are the odds that we're gonna go in someplace and we're gonna find out that the database is a mess, nothing's normalized, it wasn't designed properly, and we're supposed to be making everything work.
Well, you see all kinds of things with databases, and it's really hard to know. I think, if something's in production and it's profitable, like they've managed to find something that works. But yeah, there's always going to be, there's always going to be surprises. There's always going to be things you're like, I wouldn't have done it that way. A really classic example is just not having like data integrity. Those foreign key constraints that we talked about, a lot of times people don't include them, or those not null constraints, people don't include them because they think, oh, we'll just constrain this in Python, or we'll just use the Django ORM and that'll enforce the relationship. And that works great until you have a mobile app talking to the database too, and the mobile app doesn't know anything about Django, and it's doing its own thing. So I think there's a chance you'll have some work to do on the databases that you got to go out there and see, or they could be great. But yeah, Jack, I don't know if I have a great answer. I think it's possible.
Yeah, there's plenty of ones that are good. There's also, we've had projects come in and, there'll be columns named, such and such 3 or whatever. And like,
yeah,
like a couple of projects that I've been involved in, the founder basically was a business person who learned enough software development to get his thing out the door and then turned it over to other people. Well, his, not especially technically savvy decisions were still around. And that's part of why they bring in the experts to clean it up. So you'll find all sorts.
I honestly, I think you learn more though from working in a database like that than you do in a perfectly designed one. Because a lot of the things we're talking about are, a lot of the opinions Jack and I have are like battle scars from seeing different things that have gone wrong. So you'll learn from those experiences too. So I wouldn't be afraid of those, like just take notes and be like, okay, I'm never going to name a column Y, because that's really hard to work with a column whose name is the letter Y. But think about why, no pun intended, think about why that's a bad idea and like come up with your own opinion about it. And then that's how you become a good database developer. Okay, I think we're at the end of our time for today. I am in the Code Platoon Slack always, and Jack's in there too. Sometimes I won't offer you up for forever Q&A, but I'm always in there.
I'll see it if you send me a DM on Slack.
And yeah, I'd just like to say thank you to Code Platoon for bringing us back yet again, to Tom and to John and to Rod and to all the TAs and to all of you for sticking with us all day. Much appreciated, and thanks for your service as well. So I'm just really grateful to be back here. And anything you'd like to say, Jack?
Yeah, it's been fun. Hope that you got something out of the course today. Wish you all the best.
Thanks for going slow.
Gary, yep, appreciate it.
Covered a lot of awesome stuff in a really clear way. I appreciate it.
Yep, Jake and Jack, we really appreciate you guys coming in and doing this every cohort. I students get a lot from it. SQL is a complicated topic, databases. You guys obviously have a wealth of knowledge, so we always appreciate having you here. So many thanks to you guys for doing this. A full day of lectures. That's not easy to kind of do and share all that information. But yeah, thank you guys. We'll love to have you back next cohort. But again, hope you guys have a good summer ahead, and hopefully we'll see you guys again.
Yeah.
Thank you so much.
Thanks, guys. All right. Yeah, so thanks to our presenters there. again, hopefully you guys learned a lot. I always kind of learn a few tidbits every time they come in. So like, I think you guys were discussing in chat, and it seems like, we're, yesterday I was saying you should always do serial primary key, but it seems like serial is an outdated thing. So we should be doing as identity. So that's something I definitely should be adapting to. I forget who asked the question yesterday, so apologies, my memory is terrible. But they went over doing like transactions where you type in begin, so you can kind of do a few SQL queries, modify your data, and then if you mess up, you can roll back. So that's I know someone had asked about that, and that's something I haven't really done myself. So it's good to see them cover that. But yeah, again, hopefully you guys got a lot of it. Again, they have a wealth of information, and I'm glad they do this, and they're good presenters, I feel like. So I feel like they're, they have good examples and go through it in a good way. With that, you guys have had a long day of lectures, so there's not going to be too much more. We kind of just do a quick stand down, like the next 5-10 minutes, and have you guys out the door if that sounds good to you guys. Just want to make sure you guys are good with SQL so far. Again, a lot of new information, especially never work with databases. I know some of you guys, were looking forward to SQL because you guys weren't enjoying, I guess, CSS front end development. So hopefully everyone's kind of getting their side of things for software development. Any thoughts or questions or anything? I want to make sure that everyone's comfortable with doing the SQL basics challenge that we kind of started yesterday. Hopefully today's material will give you more confidence or just more of SQL experience. Any questions or thoughts? Again, I don't want to be talking this whole time, so I'll kind of open it to the floor.
I do have a question as far as the pull requests that we make for these challenges. Now, most everything that we do needs to be in the file that we push up, just because I know that the database isn't really viewable on the main pull request, right? There's nothing that you can like look up for what database we have going on in that file.
Correct. Yeah, you should. Yeah, you're not going to be pushing your databases. When we get into Django, which is going to be next week, by default, Django defaults to SQLite, which is essentially a text file that you can push up to your GitHub solution. So sometimes you guys might opt to use SQLite. We don't really go over SQLite. So essentially it's the same sort of structure, it's just a little different file formatting. But you're not gonna be uploading in databases. Whenever you guys submit assessments, like we just look up your database name and we could create our own databases and adapt to your solutions. Yeah, your databases will always be on your local machine, or it's not gonna be on GitHub, if that was the main question. Since you brought up pull requests, definitely try to be making pull requests. We kind of just like seeing who's attempting what. Not that, again, we're not grading you guys on your challenges, but it's kind of good to see how the class is doing. Like if we see a challenge and like there's only 2 pull requests, that's going to make us think that, okay, the class is struggling here. And that might be the case, but definitely just keep in mind, try to make pull requests, even if you have a partial solution, just get that in there so we can kind of see how you guys are faring with material. Any other thoughts about SQL or how this week's going? Any questions on the SQL basics challenge? Again, I want to make sure everyone can do that by end of day today. And again, you guys have a list of challenges that you guys are going through. So let me just share my screen. So some of them are just tutorials. So SQL basics, schema design. Again, this is a topic we're going to cover tomorrow. I think Tom's going to go over that. If you kind of want to just get comfortable with it, Tom's probably going to go over this website. I'm not sure if we've mentioned it before. It might be on the curriculum pages. But this is just kind of just a quick way to kind of model your database tables. And again, there's probably a dozen, if not more, data modeling sites out there. This one's free to use to create one schema. If you want more, you got to pay for it. But this is kind of nice. You get a nice visual of what your tables look like. So in this case, I'm modeling some probably some Uber or Uber Eats type deal. So where you have a user, they might place an order. You also have restaurants that are tied to the order, and then food items that kind of go with the order also. So like, I guess maybe if you go to Grubhub, you probably just type in like, I want a burrito, and that'll be in your food items. And that probably have a link to restaurants. Again, this might not be the perfect diagram, but again, these lines kind of show you the associations. I'm not sure how clearly this renders on your screen, but if you notice, like there's one notch here from the user ID, and there's like a 3-pronged notch on order. I'll try to blow this up a bit. But yeah, so that just means this is a one-to-many relationship. So again, whenever you have a one-to-many relationship, that's going to be a foreign key. However, if you are going to have a many-to-many relationships, you're going to need a join table. So that's where order food items, in this case, is a join table, because you can have like one order can have multiple food items in it, and then one food item can be across multiple orders, right? Like if I want to order a burrito and Jack wants a burrito, well, that's going to be a many relationship. So that that's why we have a join table here. So just understand when you need a through table or join table, whatever. Again, there's synonyms for it. Understand when you need a foreign key. And yeah, so again, this site is, what is it? quickdatabasediagrams.com. It's kind of easy to kind of get up and running. They have docs, but basically the syntax is pretty lax. You just create a table and just gotta get familiar with their syntax. This isn't any like standardized syntax for creating these diagrams. But again, just nice visuals. And the good thing about this site, and I'm sure other sites do it, once you have your models, you can go to export and export it as Postgres SQL, and they'll kind of create an auto-generated SQL file for you. Now I'm saying this just for convenience. I'm not saying you should always rely on this to write your SQL for you, because we want you obviously familiar with writing raw SQL. Just for this week, again, going forward, we're not gonna be writing too much SQL once we get into Django world. So please, yeah, don't abuse this option, but it's just good to point out that I'm gonna click on that. Apparently I'm missing a field type. That's not good. Restaurant name, that should be a bar chart. I think, yeah, I didn't complete this diagram whenever I was creating it. But yeah, you can export it. Assuming I don't have errors here. Okay, forget that. It's theoretically possible to export it once I finish all my errors. So not sure what the issue is here. Foreign key, user ID. Any questions on data modeling? So again, Tom's gonna go over this more tomorrow. So that challenge, if you're struggling with that, just hopefully you get it accomplished by end of the day tomorrow. Otherwise, I know we say do these in order, but some of these tutorials are probably good to jump ahead to. So again, I'm not sure why we say do it in this exact order, because again, these tutorials are pretty basic and give you a better understanding of SQL. So again, if you get stuck on these, just feel free to jump ahead to ones that seem more doable.
Why is SQL queries on there twice?
One is an article, the other's, oh, sorry.
Yeah, go for it. No, Jack kind of answered the question there. So yeah, I think one's a challenge, one's just more information for you guys.
Oh, okay.
But I'm not sure. Yeah, again, I've not investigated all these.
So I'm not sure if it's something that I missed on the initial the install fest. But when I was starting the SQL basics, there was the PSQL start command. And I don't know, I was just a little confused about that. I don't know if it was something that I just missed or.
I am not familiar with the start command either. Is anyone?
Well, PSQL didn't work at all until I looked up like brew PSQL start, and then I was able to actually use some kind of PSQL. Otherwise, my terminal didn't recognize it at all.
Okay. So yeah. So your machine should have a Postgres server running. During the install fest, there's like a command you had to run to have it always like kind of whenever you launch a machine, it should auto run the server. So I'm not sure if for whatever reason your system might not auto get that server running. So psql start might boot up that server would be my guess, but I am not confident about what I just said. So
that might just be part of the M1 chip and one of the other issues that I was having with that. But
yeah, I actually just updated the install fest docs yesterday because at least one or two students were having issues with M1. So there's two commands I need to run that might solve it for you. I forget. I think I was working with Reno, and Reno had an M1 if I was correct. And then yeah, we had to do a few things. It took a while, but yeah, your file path is gonna be a little different. But you try running those two commands. I'll point you to it or Slack it to you. After this, we can't find it. Give that a try. So yeah, you shouldn't have to run psql start because I've never ran that command since I've been here. But yeah, again, if anyone else is having any psql issues, make sure again that you should be reaching out and hopefully we can get a solution for you. I know another student was having an issue on Windows. I'm not sure if that was solved. Jack, I know you said you were going to reach out to the login issue get solved, or was that still pending?
I don't know. I mentioned work out with one of the other students, but I don't know if we got Steven squared away.
Okay. If anyone else is on Windows, again, I think other students have dealt with this, where when you try to run Postgres, it defaults to your Windows user, but there's like another default, or there's another Postgres user that does work, or something like that. Again, I'm not on Windows, so I can't speak to it accurately. But if anyone else is on Windows and has had that issues and has solved it, I think Steven was running into it. Steven, do you have any follow-up on that?
It only works if you like run it through just the Postgres user, because when I installed SQL initially, it asked for like a master password, so I just used my password, but it's weird because it always asks for your user. So whenever you log on to a Windows machine, so I thought I just use that password, but it doesn't work, and you have to do some weird stuff in the data flow in the SQL to check something.
There's a kind of a kludgy way of doing it through the pgadmin 4. I can show you after we finish up here.
Gotcha. Yeah, thanks for helping each other out, guys. But cool. Yeah, again, if anyone else is having Postgres issues, just post it in the question chat, and hopefully someone has a solution, or we could try to fix that. Because obviously we want you to be working with databases in SQL.
Cloud9 works great though. It's already working.
Awesome. Yeah.
Yeah, I was gonna say, yeah, Cloud9 works perfectly fine.
I ain't paying for Cloud9.
Honestly, I've only paid like 50 cents so far.
Yeah, I got that big old goose egg. I haven't paid anything so far.
Is it limited based on bandwidth usage? I'm not sure how Cloud9 works.
I think it is. I mean, because every time we're not using it, I always have it closed out. So
okay.
Yeah, it powers down after like an hour of inactivity.
That's cool. Yeah. So I think Chris was the one that set up the Cloud9 setup. So it's good to hear that's working flawlessly. But yeah. Okay. Any other questions on SQL stuff? Again, Jack and Jake, glad they could come in. Hopefully you guys enjoyed that presentation. Again, I know it was a long day, but again, they have a lot of experience and knowledge to share. So hopefully that was a good session for all you guys. Any other comments or feedback?
Or it was awesome.
Yep. Yeah, I think they're great presenters, and they share the material in a good manner. Like I can say I'm kind of guilty of this, but like I've had presenters where they have a lot of knowledge, but they're really boring to listen to. I feel like Jack and Jake are a pleasure to listen to. Like they speak with passion and have good examples and stories to tell. Any other questions on the assignments from yesterday, today, and next day? These 3 are the 3 days. These 8 assignments are the same. So as in, you should be working on them each day and trying to get through this by the end of the day tomorrow. And we're going to be going over schema design. So again, a little more designing. It's very, very similar to OOP concepts in terms of creating these separate tables, creating relationships. So hopefully you guys still have that part of your mind still kind of sharp. What else do you guys have to say?
So in an ideal world, we would have taken away exactly perfectly all of the information we've been given today. I was not able to do that personally. Where should we kind of be at with kind of like,